Hello team, welcome to my session on Coffee with Prabh, and today we're going to discuss about AAISM Domain 3. It is one of the technical domain of AISM, and thanks for sharing a great response on my Domain 1 Domain 2 which motivate me to make this Domain 3 video. My name is Prabh Nair, and for more information you can check my LinkedIn profile. So without wasting a time, let's get started. So this domain is divided into 5 categories. Part A, AI Security Architecture. Part B, AI Lifecycle Management. Part C, Data Management Control. Part D, Privacy, Ethical, Trust and Safety Control. And Part E, Security and Control Monitoring. 38%, around 34 question we can expect from this particular area. So if you're a person who preparing for this certification, Domain 3 is very, very important. So we're going to start with the Part A first, which is called as a AI Security Architecture and Design. But before we jump into AI security architecture and design, let's understand first AI foundation. Okay, so think of this diagram like a circles inside the circles. And the reason why I'm talking about this, because this foundation is very important for you to know from exam point of view, especially deep learning is testable in the exam. Generative AI is testable in the exam. There is a one dedicated video I made on Gen AI risk. Make sure you should check that also. So when I say this diagram, AI is the biggest circle you can see. Okay. So what is AI? AI mean any system that try to perform the tasks that normally need a human intelligence, like understanding the language, making a decision, recognizing an image, solving a problem, recommend something, or answering a question. So if you take example of ChatGPT, you enter a query, a ChatGPT provide the output. So AI is a machine doing an intelligent task. Now, question is how they can do the task. In a similar way, the way we see, when you are in a school. Okay, so we have a class 1, class 2, class 3, class 4, class 5. So as you move from 1 to 2, 3, 4, 5, 6 class, you build your intelligence, you gain the learning, you get a knowledge. And according to that, once you pass the school, you are in the position to handle all kind of a query. So same like machine is inside the AI. Okay, so machine learning is basically like a brain of AI. Is a type of AI where the system learn from data instead of manually program for every rule. So instead of telling the system if email has a word, mark it as a spam, we give it a many example of spam and non-spam emails. Then it learn the pattern and according to react. So you can say machine learning equal to AI that learn from data. Now, third thing is called as a deep learning. Now, when we're talking about deep learning, now what is deep learning all about? Deep learning is a component, is a sub part of a machine learning. Okay, it use neural network inspired by how the human brain process the information. It is actually useful when data is complex, just image, speech, video, and all that. So you can say like that deep learning equal to machine learning using a neural network for complex pattern. You have seen a lot of diagram in my domain 2 also. So let's say example, this is my deep learning. Okay, so it has a neurons. As data is basically passed through these neurons, it become more intelligent. Same like when you pass through multiple standard of classes, you become more intelligent. So same like that. Now this is the exam question. The biggest concern in deep learning is how this neuron react, how the neuron is basically processed. We cannot able to understand that. So biggest concern with deep learning is that their model. Okay, their model. And Gen AI is inside the deep learning. So generative AI create a new content. It create a text, image and all that. And ChatGPT example of a Gen AI because it generate a new text based on your prompt. Now, one thing is very important here is called as a data science. Data science, if you can see, shown as a separate but overlapping circle because it is not exactly a subset of AI. Data science is about extracting insight from data using a statistics, using a analytics, using a visualization, using a machine learning, business understanding. So data scientists may use machine learning or AI, but data science also include the non-AI work like dashboards, reports, trend analysis. So data science using a data to find the insight and support the decision. So more of the story is that AI is a broad field. ML, learn from the data. DL, use neural network. Gen AI, create a new content, and data science extract insight from the data. So data science analyze what, so let's take example Netflix. Okay, if you take example Netflix, so data science analyze what user watch. So AI recommend what user may like. machine learning learn from the user behavior, and deep learning understand the complex view pattern, and Gen AI create a movie summary for poster. So this is how you can able to take the thing. So Gen AI is a subset of deep learning, which is a subset of machine learning. Can the AI work without machine learning? Yes, but it will not be that intelligent. Same like, machine learning is basically supporting the pattern of the functions and everything. Now we're going to discuss about some part of a machine learning in detail. So before we jump into core part of domain 3, I want to talk about the part A, some kind of an infographic. Okay. Now in this section, as a AI security, we're going to discuss about enterprise roles. What is the role of a provider, producer, customer? We're also going to discuss about data foundation, which is very, very important for us to understand. Then we also need to understand how it impact the regulatory, which include the regulation evolved, because according to regulation, you need to customize your AI solutions. You need to build your AI solutions and make sure it should not creating any kind of societal impacts and all that. Then when you're building an AI, what is a secure by design process, transparency, accountability, how do we balance that? We need to maintain the uniformity. So we need to track the model settings, parameters. You need to select data model based on data and objectives. And we need to make sure it should not create any kind of a negative impact. And any kind of a changes in the AI need to go through a change management process. And in the case of emergency, how to fix, what is the rollout. All those things are part of an AI architecture. That's something we need to discuss. And that I'm going to discuss in this entire domain. Now, in order to start this section, part A, we need a very clarity. His role clarity is important because role clarity decide the data foundation, secure by design configurations and all that. Because if you are an AI provider, you have to have a more control. But if you are an AI customer, then you have a limited control. That is why the role clarity basically play a very important role. Then data, what you're going to feed, that build the trust. Model is the most important brain of AI. And then around the security and everything. So first thing we need to discuss, which is very important, is called as a AI type parameters. Okay. So what we did here is that we have divided the AI into two sections. Okay. One is called as a functionality level and one is called as a capability level. Now, what is functionality? Functionality, you can say, explain how AI is going to work or how AI is going to operate. That is basically called as a AI functionality. Let me give an example. So how does AI work? Does it remember? Does it learn? Does it understand the emotion? Or does it have a self-awareness? So based on that, we have categorized the AI into four functionality. One is called reactive. One is called limited memory. One is called theory of mind. And one is called self-aware AI. Okay. So when we're talking about reactive is like responding only to the current inputs. Okay. So second is called as a limited memory, which use past data or recent experience. So self-driving car use actually a past and current sensor data to make a decision. So that's a live example of limited memory. And if you want to take an example of reactive machine, so AI react only to the current input as we discussed. It does not remember your past experience. And the best example of this is IBM. It's called as a Deep Blue chess system. So what it does is it analyzes the current dashboard, chessboard, and select the best move. But it did not learn from past game during they play. So they actually react to the current input, and based on that, it does that. We already discussed about limited memory, which is a very common thing we use: self-driving car, Netflix, YouTube recommended system, fraud detection system. All are basically useful, and this is something testable in the exam because it uses past data for better current decision. In threat intel and all that, we are using this. Next is called as a theory of mind. Theory of mind, AI that can truly understand the human emotions, belief, intention, social context. There's no fully achieved real theory mind AI today, but partial you can see emotion aware chatbots, social robots like Pepper, AI assistant that detect the sentiments, emotional tone. These systems may detect emotion pattern, but they do not truly understand the emotion like a human. So theory of mind still developing, not feel real today. Last is called as a self-aware AI, which can be a future where consciously, self-awareness, emotions will be there. There's no real world example today right now, but you can take an example of super fiction like AI robot who understand the emotions. So robot movie you see, na? So robot understood the emotions. So Rajnikants are already far ahead. Okay. So self-aware AI is a hypothetical, not available today. So moral of the story is that how it actually function. Okay. So functionality level tells about how the AI work, and capability level tell how intelligent it is. Okay, so that something is part of a requirement. Now when you're talking about core capability level, what can the AI do? Is it a task specific, is it a human specific, or it can go beyond the human intelligence? So based on, so capability level talk about, how broad, how powerful the AI intelligence is. Okay, what they do is this, but what is the level of information they carry, how much they carry? So what can the AI do? Is it a task specific, human level? That something come to the picture. So when we're talking about ANI stand for the artificial narrow intelligence, which perform one specific task or domain. Example, chatbot, spam filter, recommend systems, and all that. Okay, so it was exclusively designed for that. Second is called as a AGI. AGI stand for artificial general intelligence, which can perform the intellectual task like a human across many domains. Currently, it is still half of the thing done by ChatGPT, but not completely. And third is called as a ASI. Again, it is actually in a theory. Okay, so that something is there. So if you take example of self-driving car, okay, self-driving car is designed mainly for driving, not for the human task, right? So it is based on the capability which is called as a artificial narrow AI, which using a functionality of limited memory. That's how it works. So functionality level talk about how does AI behave, but capability level talk about what can AI do. Focus of functionality is memory, reaction, learning. Capability level focuses on intelligence, scope, and power. Okay, so that something is basically part of the function. So one thing we need to understand, perhaps still not clear about the correlation. So let's take it this way. If you take example of functionality view, okay, a self-driving car, use camera, remember recent records, react to traffic. So by functionality it is, okay, that is basically there, right? Because it use the past recent data to make a current transition. But self-driving car designed mainly for driving. It cannot write a legal contract. So by capability, it is a artificial narrow intelligence because it perform one specific task. So that's how we are talking about the correlations. Okay. So summary is that functionality tells how the AI behave, and capability tell how broad is the AI intelligence is. So self-driving car is a limited memory by functionality, but ANI by the capability because it was designed to perform the one particular task on. So here you can see reactive machine, the most basic form of AI we already discussed, respond to the current inputs, not a memory of past experience, does not learn, good for specific rule based, deep blue, industrial robot, smart home devices. That is called as a reactive machine. Okay, most basic form of AI. Okay, second is called as a limited memory, use a past data, learn from patterns, mostly wise used today. Autonomous vehicle, chatbot, Siri, recommend systems are the example limited memory. Third is called theory of mind, ChatGPT in a process, not completely, you can say. And last is called as self-aware AI, not currently in use. So reactive is no memory, limited is learn from the past data, TOM is understand the human emotion, and conscious AI not arriving today. So these are basically the examples we have. Now, as we said earlier, when you're talking about AI-based capability, it is a current most form of AI, okay? So it is a task-specific work with the limited domain, high accuracy, no true human-like intelligence. Now they are using the category of reactive and limited, which react to only current input, no memory, and use the past data and all that. So example of ANI is Siri, facial recognition, language, image, autonomous, and all that. Okay. On the other side, artificial intelligence that perform intellectual tasks human can do, not limited to one. So sensory, fine motor skills, problem solving. This is basically current we have. So we have a good progress here, but not completely. One is basically theoretically we have a hypothetical is ASI, artificial super intelligence, which can do the intellectual task better than human, because see, by end of the day AI was trained on the old data, right? So ASI go beyond the human intelligence, which is a hypothetical future AI, which we can see right now. So now we need to learn about the three type of machine learning systems, or you can say three main way a machine learn systems learn. So think of a machine like a teaching a student. Okay, we're taking a same reference, teaching a student. So when you are a kid and all that, how teacher used to teach you so that you can able to remember, right? So think of a machine like a teaching a student. Different students learn in a different way. Similarly, the machine learning models learn in a different way. The first is called as a supervised learning. Supervised learning is basically where the machine trained using a data where the correct answer already given. So it is more on a label base. Let's take example. Okay, imagine you're teaching a kid about fruits. Okay, you're teaching a kid about fruit. Beta, this is apple, this is banana, this is orange. So you label them already. Okay, so after seeing many example of apple, banana, orange, the child can identify the new fruit. In similar way, we basically label the data. This is spam, not spam. So email is an example which is mentioned here. So if the keyword talking about win a free prize now, it should be labeled as a spam. Meeting schedule is not a spam. So the model actually learn from the examples where the answers is already known. So supervised learning, teacher give question and answer. But problem in this is we have to label data in more faster manner. More activities, more efforts are required to label such kind of a data on a regular basis, which is basically a concern for us. Sometimes it is expensive also. Second is called as unsupervised learning. Here the machine get data, but not a correct answer are given. Okay, no correct answer were given. It has to find the pattern or group its own. So let's take example. Okay, so let's take example of imagine. Okay, imagine you give a child a basket of mix item. This is a basket. Okay, it's a basket. It has a coin, it has a pencil, it has a toy, and it has a button. So you do not tell the child what they are. The child start grouping, or you can say the child start grouping similar looking item together. So the dots you can see here are grouped into cluster. The model is find a similar data points and putting them together. Require a lot of efforts there. Okay, so let's say example, there's a company. So company may group the customer based on the shopping behavior, budget buyer, premium buyer, frequent buyer. But system discovered this group by itself. So unsupervised learning is no answer, only pattern, good for detecting a new attacks and all that. Third is called as a reinforcement learning, where the machine learn by trying action, receive feedback. Today, Netflix and everything is using a machine learning, reinforcement learning, because based on interest and all that, YouTube, based on interest, you see the video, right? So they say good action, which is called reward, bad action is a penalty. So think of a training a kid, or think of a training a kid is, dog sit correctly, get a treat. Dog does not follow, not a treat. So same thing we have here. So over time, the dog learn what action give reward. So same like the action in the case of agent, take the environment like reward for the good action, penalty for bad action. So Netflix, YouTube, they use the same concept. So summary is that supervised learning is actually learn from label example where the teacher give answers. Unsupervised learning find the hidden patterns, and the reinforcement learning is actually teacher give the answer. Learn from the rewards and penalty and trial and feedbacks. That's something we're talking about. So let me give an example, desi example. Okay, so let's example your wife say this is how you should make a chai. First boil water, then add tea, then milk. If you do this, it is correct. Husband follow this instruction. So learning from the correct answer, right? That is called as a supervise. Now husband open the kitchen and they group things by himself, all masala together, all snack together, all utensil together. So wife never told him the label. That is called finding a pattern. Now third is called husband make chai. If chai is good, wife say wow, perfect. If bad, wife give a silent treatment. So next time husband basically improve. So this is how we basically take the examples. Okay, so summary is that give full instruction is supervise, finding a pattern himself is unsupervised, husband learn from wife reaction is basically reinforcement learning. That's something we had. So as we discussed about supervised, unsupervised reinforcement learning, but under each and every learning, we have a different way to learn the patterns and everything. Okay, so first, and this is something testable in the exam also. Okay, it is testable in the exam. So it is all about how they basically learn and everything. So first we're going to discuss about supervise, where we identify them, this is image, and then based on that they basically learn, right? So under which the first one is basically called as a linear regression. Linear regression is called as a predicting a number. So any question talking about you can say any question talking about predict numbers, or it's mentioned price, sales, salary. Okay, let's take example this way, or keyword is talking about numbers, money, monetary and all that, then answer is linear regression. Prabh, an example. So I'm building an AI tool, okay, in which you need to feed the house size. Let's say example, house size, okay, number of rooms, location, and more important, age of the house. And based on that, it can predict it will be 80 lakhs, 90 lakhs, and all that. So linear regressions predict the number. Okay, so today we are using this for house price prediction, salary prediction, sales forecasting, temperature predictions, and all that. Second is called as a logistic regression. Logistic regression predict the probability and then classify. It is not a confirm. It answered the question like, is this yes or no? Is this spam or not spam? Is this, so it comes with a question mark. Is it clear? That's why this is used in the email spam system. So let's say example, there's an email system which check the email and say 92% chance this is spam. So it is classified as a spam. So any question talking about yes or no, predict. Answer is basically logistics, or you can say logistic regression. It is used in spam, not spam, fraud, not fraud, loan approval, reject, disease present or not. That's basically we have. Now here that both look same, right? Somehow same, but there's a thin line difference that we need to understand. Because if you take example of linear regression, it is used when you want to predict the number. Okay, what will be the house price? So linear regression give a continuous numeric value. So how to remember? Predict the amount and predict the number. Okay, whereas logistic regression is used when you want to predict the category. Okay, predict the category, where you predict the probability. Okay, that something is basically we have. So that's how we see that. So any question talking number, answer is linear regression, and any talking about probability category, answer is basically logistic regression. 0 to 1 logistic, any number is linear. How much is come under the linear, yes or no, come under the logistic. Okay, so let's example, wife asks how much will the monthly grocery will be, so around $12,000. That is basically called as a linear regression because answer is number. Will you forget to bring a coriander again? So here 90% chance is yes, he will forget. So that is called as a logistic regression because answer is a probability and then yes or no. Okay, so how much is the linear and which class, yes or no, is logistic. Next is called as a tree-based model, which is also called as a decision. So it asks a series of questions actually and reads a decision. Let's example for a loan approval. Okay, let's say example for a loan approval. Is this income above the 50,000? Is the credit score above the 750? Does the person have an existing loan? And then we take a decision. So decision 3 is all about if and then. If the question talking about if and then decision logic, then answer is basically called as a tree-based model. Is it clear? Because it is commonly used in credit risk, loan approval, customer predictions, medical diagnostic support. That is basically we have. Next is called as a support vector machine, SVM. So SVM, it tried to separate different category with the clearest possible line or boundary. Imagine we have a two groups. Okay, so we have a group called cat and we have a dog. So SVM tried to draw the best boundary. Okay, SVM tried to draw a best boundary so the new image can be classified correctly. Okay, so SVM is basically used for image classification, text classification, face detection, cancer. So any question in the exam talking about image. Okay, face detection, cancer classification, biometric, answer is basically SVM. One more example I can give you. So we have a AI system. Okay, so you want to classify students into two groups in that, serious student and casual student. So you look at the two factor, how much hour they study and how much practice question they have attempted. So now you plot a student on a chart. So SVM try to draw a line that separate the both group, but it does not just draw just any line. It draw the line that give the maximum gap between the both group. So SVM want a safest preparation. Okay, which boundary basically separate the group with the widest possible distance. And this distance is called as a margin. That is why it is called as a SVM, support vector machine. So the closest the point near the boundary are called as a support vector. Okay, so one student almost looks serious, but it is actually casual. But another student almost look casual, but it is actually serious. So these boundaries can help the SVM to detect. Let's example, wife want to predict, will husband bring coriander or forget again? So she observed, did he write down? Did he call from a market? Is a cricket match is going on? Is he distracted? So now there is a two classes, will bring coriander, will forget the coriander. So SVM basically draw a boundary between these two behaviors. But SVM focus most on the borderline case, like he wrote it down, but cricket match is on. So that borderline case help to decide the final prediction. So SVM is useful when you need a clear classification. Okay, image, face, spam, and all that. Is it clear? That something is basically we have. So, but it look like a logistic regression. See, logistic talk about predict. SVM talk about final. Logistic output is what is a chance. Support vector, which side of boundary? Will he take a in-laws or will he take my chance? So example like 80% of a chance is spam. Or in SVM, this email fall on a spam side. So best memory is logistic, talk about the probability based classification, and SVM talking about the your maximum margin classification. That's something we are using. And if you want to talking about cybersecurity, you have a file with the features like file size, API call, suspicious strings. So SVM tried to separate a malware or binning file. So it find the best boundary between the malicious and safe file, and then it take the parameter. So that is basically called as a SVM. Okay. After the SVM, which is most testable in the exam, is K nearest neighbor. And I always struggle with that because I'm not came from a background of AIML. So K nearest neighbor is a supervised learning algorithm. It predicts the class of a new item by checking which existing example are close to it. Let's example, tell me who your nearest neighbor are. I will tell you what you probably are. So we say your environment decide your future. If you around with drunkards, be a drunker. If smokers smoke, so that's what. So let's say example, you have a new student in the class. So a new student joined the cybersecurity class. Now you want to predict whether he will pass or fail. So you compare him with the past student based on the attendance, practice questions, study hours, and all that. If his 5 closest past students mostly pass, so can predict the student will pass. If most of the close students fail, the can predict student will fail. So K is equal to number of nearest neighbor. Okay, so if I say K equal to 3, check the nearest 3. If I say K equal to 5, check the nearest 5. If I say K equal to 7, is called 7 nearest example. So that's something we have. So we can use this in our email systems also. Or let's say example, husband enter into shopping mall. Okay, so wife want to predict, will he come back quickly or get distracted? She compare him with a similar past situation. Cricket match day, phone battery low, liquor shop, shopping list clear, wife called twice. If both most similar past cases ended, him getting distracted, prediction will be he will distract again. This is called KNN. So that is basically called, so if the question talking biometric and facial recognition and between two options, SVM and KNN, so answer is facial recognition for KNN because that is the best for biometric also. So KNN basically think about which is the old example are closest to the new example and based on that do the authentication. So difference is that logistic talk about probability, SVM talk about the boundary, and KNN talk about the similarities. I repeat again, logistic talk about the probability, SVM talk about the boundary, and KNN talk about the similarity. Example, what is the chance is logistic. Okay, which side of the line you are, that is called SVM, support, how to support. And who are the nearest neighbor is basically KNN. So 90% of the chance spam, logistic. Spam side or not spam side, SVM. Similar email will be flagged as a spam, that is called as a KNN. So these are basically the example of the supervised learning. We also have a last which is called as a naive Bayes. So naive Bayes is basically use probability to classify data work well on the text data. It is used for spam detection. It check which category is most likely based on a word or feature present. Example, email contain the word like free, winner, urgent. High probability this is spam. So it classifies as spam. So naive Bayes is basically use a probability based classification and it is used in the spam detections and So using a spam detection, but it looked like a kind of a logistic also, because in logistics also we're doing the same thing, we're talking probability. Now there's a difference. Both actually predict class category. Okay. Both use probability. Okay. Both use probability. Yes. Okay. But main logic is logistic regression learn best weight for each feature, whereas a naive Bayes calculate the probability of each feature. Example, 85% chance, it's basically pass. But naive Bayes use high attendance, good marks, multiple metrics, and then they basically take a call. So naive Bayes is closest to logistic regression because both do probability based classification, but logistic regression learn the mathematical decision boundary, whereas a naive Bayes calculate the probability from a features, evidence, and all that. That's why it is used for spam detection. So how to remember? If the question talking about number, then answer is linear regression, probability and class, logistic. We're talking about the set of questions, decisions is tree based. If the question talking about boundary, then SVM. If the question talking about nearest, then answer is this one. If the question talking about probability from evidence, then answer is basically naive Bayes. Now we're going to discuss about the unsupervised learning. See, at least in a supervised learning, we train them on a specific data set and all that. But in unsupervised learning, we are not trained on a specific data sets. They use the model without an answer. There's no label like spam, not spam, pass, fail, fraud, not fraud. So the AI has to find the hidden pattern by itself. Okay. So as I said, now imagine you have a students in a class. So no one will basically tell you, who is a beginner, intermediate, advanced. So you look at the test scores, study hours, attendance, practice questions, and then you naturally group them. Weak student, average student. So that is called unsupervised learning. So algorithm used in unsupervised learning is called K-mean cluster. So K-mean clustering mean grouping the similar data into fixed number of group. Prabh, an example. Let's say example customer segmentation. So when I take an example of customer segmentation, hypothetical scenario, okay. So we have a customer segmentation. So we have categorized into premium customer, okay, budget customer, and occasional customer. So memory line here is that it make the K group of a similar data and based on that do the prediction. That is called as a K-mean clustering. Second is called as a hierarchical clustering. Hierarchical clustering is actually create a tree like a structure of group. Okay, so we normally map or group the similar document, right? To start grouping smaller items and then combine them to group, like family of tree of group. That is called as a hierarchical clustering. And third is called as a principal component analysis, where we reduce the complex data into few important features. Let's say example image, which has 1,000 of pixel, right? So PCA will reduce the complexity while keeping the important information. So it simplifies the large data without losing a key meaning. That is called as a your PCA. So let me give you an example again. When I say hierarchical clustering, it does not simply say make 3 groups. It actually shows how small groups combine into big group. Think of a family tree. Okay, so we have a student A. Okay, student A and student B. They are very similar, so they become a one group. C and D, based on data and all, they become a one group. So those small group may combine into bigger group. So that's why it is called as a tree like a structure. So if the question talking about hierarchical clustering, family tree of group. So we look for the words like hierarchy, tree structure, nested group and all that. Now the last is called as a PCA, principal component analysis. It used to reduce the complexity. Let's example, you have a student data of 50 columns. 50 columns. Okay. So you will have a attendance, mock test score, study hour, sleep hour. This is too much data, right? So PCA reduce it to the few important factors like study discipline, practice strength, exam readiness. So instead of 50 feature, you work for the 2-3 important combined feature. So the question talking simplify data, reduce dimension, the answer is basically PCA. So how to remember? If the question talking about make a fixed number of group, that is called clay cluster. Build like a tree group, that is called as a hierarchical. Reduce many features is called as a simplified data. That's what we have. So let's take one basic example. Imagine there's a coaching institute which has 1,000 students. So management say divide the student into 3 batches. So AI will create a beginner, intermediate, advanced. That is called K cluster. Okay. Now on the other side, first I will group a very similar student, then combine a smaller group into a bigger group, weak concept, strong concept, and this is how we basically create. That is called as a hierarchical. We may have a 50 students performance factor, but make it simple: knowledge level, practice level, consistency level. That is called reducing the complexity. That's how we basically do the things. So K mean a group data into cluster, hierarchical cluster build a tree of clusters, and PCA reduce many feature into the few important feature. That's something we are using. Okay, now the advanced version is called as a reinforcement learning. Reinforcement learning, by interacting with the environment, look for the good action, bad action, and based on that do the better. Now reinforcement learning use some terms. They have first term called as an agent, okay, which is called as a learner. Second is called as an environment, the place where the agent act. Third is called as a state, a current situation. Fourth is called as an action, what the agent does. Fifth is called as a reward, a feedback. And fifth is basically called as a policy. Agent is learner, environment is basically the place, state is called as a current action, so current situation. Action is basically all about what the agent does, and reward is feedback after the action. And policy is called as a strategy for choosing the action. So let's take example, there is a robot, okay, it moving inside the room. So agent is a robot, environment is actually room, state is what? Robot is near a wall, action is turn left, reward avoid collision, and policies learn strategy to move safely. So now if we're using a Q learning, so learning teach the AI which action is best in each situation. So it create a memory table called as a Q table, and the table basically store in this situation which action give the best reward. So that is basically the example of Q learning. Okay, simple example is every step. Should I go left? Should I go right? Should I go forward? Should I stop? So after many try, it learn when I'm near the wall, we have to turn it right, give the better reward. So best action for each situation. That is called Q learning. Same like, husband want to avoid argument at home. So wife is angry, dinner is late, cricket match is on. So possible action: argue, stay silent, apologize. So after experience, he learn in this situation, bring the ice cream, give the best reward. That is a Q learning. Second is called as a deep Q network. Deep Q network is also called Q learning, work well when situations are limited, but real world situation can be very complex. Example, autonomous driving, video games, robotics, cybersecurity response. These are too many possible states to store the Q table. So DQN use a neural network to estimate the best action. So let's take example of the self-driving car. Self-driving car can consider traffic lights, road sign, pedestrian, vehicle speeds. So too many combination. And that is what we use. So DQN use a deep learning to decide when to brake, when to slow down, when to accelerate. That's what we have. Okay. So DQN is like a husband managing a wife, mood, mother-in-law, electricity bill, and all that. So too many state, right? Simple memory table fail. So now he need a deep brain model. That is called DQN. Third is called as a policy-based method, which directly learn the best strategy. They do not focus mainly on storing action, which is value like a Q learning. They learn according to action. So let's say example, robot we have. So it arm need to pick up a glass. It must decide how much force to apply, what angle, how fast to move, when to stop. So instead of calculating value of every action, it learned directly from a movement strategy. That is basically called as a policy-based method. So any question talking about learn value of each action, a simple environment, then answer is basically Q learning. Use a neural network to estimate the best action. Complex environment, then answer is deep Q network. Directly learn from the strategy, learning and all that is basically called as a policy-based method. So these are the functions we have. So supervising learn from labeled data, unsupervised learning from finding patterns, and reinforcement learning by interacting with the environment and maximizing reward. So remember, supervised predict, unsupervised discover, reinforcement learn by the reward. That's something we have. So now we need to discuss about the risk in supervised learning. As I said, how do you train your kid? How do you train your model? According to that, it react. So one of the biggest risks is require large volume of high quality labeled data. Integrity is the biggest concern. And we have to label every data. So human labeling is basically concerned. The ChatGPT, OpenAI and all that, they have spent huge amount of money for that. What if there is a bias in the training data which can produce a bias outcome, right? Because we have told the model this minister is a good minister, this minister is a bad minister. That is why sometime OpenAI, Google and all that was doing some kind of a discrimination against India also, sometime, or other countries also. So poor data quality lead to the inaccurate predictions. And more important, human involvement is high. So if you get a question in the exam, which type of learning required a good amount of human supervision, the answer is supervised learning only. Because if we don't involve the human supervision from as early as possible, it can lead to the concern. So governance focus is we need to validate the data quality, we need to check for the label accuracy, test for bias, review the model performance, and more important, monitor the output after deployment, because there is a possibility after set of time the model can be drift and all that. So that's something we have to look for when you're talking about risk in supervised learning. Now we're going to discuss about the risk of unsupervised learning. Unsupervised learning not use any data sets, right? So it use unlabeled data. So hidden pattern may be misunderstood because it is all about how they group together. Another important thing, the model may create an incorrect or meaningless cluster because they are creating their own set of metrics and all that. The bias can still exist in dataset even without label. It's all about how the model weight was trained. And sometimes difficult to explain how you basically create a group. So what is the governance is validate the data quality before analysis, review whether cluster make business sense, very, very important, check for the bias in a discover pattern, and monitor the output, and more important, document the assumptions. That's very important here. Now next is basically called as a risk in reinforcement learning. So it learns from rewards and penalty. What you tell them right, they will believe it right. What they tell them wrong, they believe in wrong. So autonomous action may create a safety ethical operation risk if you don't fine tune properly. Model may find shortcuts to maximize the reward, and sometimes what if an unsafe exploration can cause a harm. Difficult to predict the behaviors, and high dependency on the simulation quality and environment design, because according to that we will create the factor. So governance is define the reward function carefully. We need to spend good amount of time in the initial stage, what to reward, what not to reward. Test in a control environment, make sure for critical decisions we need to apply the human in the loop oversight, set the safety limit and involve when to involve the human, and monitor all the behavior and all that. That's something we have to look for. Now, one of the section of deep learning is Gen AI. Everyone knows that, right? So we're using a Gen AI to create a new content. So it can generate text, image, video, code, and all that. But quality and risk of Gen AI depend heavily on the trained data. What data was trained? Initially, when ChatGPT was introduced, it was trained on the 2016 data and all that, right? So training data is the most important part. How the model was designed, how it gives priority, what is the usage context, and more important, we need a proper governance control. Now we need to understand some legal and ethical risk in Gen AI. See, one is that definitely the documents, what they create, the images, what they create, the audio that it creates some legal, ethical, reputational risk if it has a hallucination, because AI generated content may include the harmful content, misleading content, protecting the intellectual property, bias and inappropriate output is there. So the key risk, if you ask me, copyright infringement, like, someone can copy someone's data. IP ownership disputes, it was actually owned by someone has used that again, and they say, okay, it was generated by me. Harmful content distribution, which can be having abusive words and all that. Sometimes misinformation, that's the biggest concern in Gen AI. Legal liability for AI developers, okay. They are not even accountable, but still, okay. And ethical misuse of generated contents. So these are the different type of legal ethical risk we have for the system. Now we are introducing a new concept which is used by a lot of companies, agentic AI. Okay, so what is agentic AI? Okay, so before I jump into agentic AI, I want to talk about the Gen AI first. Okay, so we discuss it. Okay, so this is basically the chat GPT. So you normally enter the prompt, write an email to the customer, and it reply with the email draft. Okay, this is a Gen AI. Agentic AI is basically a system. I sent a prompt, resolve customer complaint. So what the agentic AI do, they read the complaint, they check the CRM record, they understand the issue, they draft the reply, they create a support ticket, they offer refund. That is agentic AI. It taking step toward the goal. Okay. So normally what happen, you ask any assistant, what should I pack for Bangalore? It give you a list, but agentic AI is basically act like an assistant. It plan your Bangalore trip. It check your calendar, book a flight and everything. So agentic AI is a next evaluation AI assistant. It can make the decision and take the action to achieve the specific goals. Okay. It can act with more autonomy than basic. It can perform a specific task, and it is more a goal oriented function. That's something we have. And another simple example here is, we have a normal chatbot answer to customer question, but AI agent check the customer record, raise a ticket and all that. So biggest concern in the agentic is it basically specialize the work for tasks, support innovations, improve problem solving and all that. Okay. And the use case like customer service automation, healthcare diagnostic, manufacturing process, workflow management, financial risk management, sales support and all that. But the biggest concern, the risk is that poorly defined goal. If you have not defined the poorly goal, if you define not a proper goal, it can lead to the bad decision. And if you get a question in the exam, what is the biggest concern agentic is autonomy. If you have a less autonomy, less human interaction, it can backfire. Human oversight is a most important thing required in agentic AI, especially for the critical decision, because wrong permission can allow agent to misuse system also. So make sure the agent must be logged, monitored, and controlled. So remember, for the exam, agentic AI equal to AI that can act toward the goal. But the most important criteria is required is the human oversight for the critical decision, which is the most important part we have. Next thing, we're going to discuss about the neural network, which is part of a deep learning. Now, what happened is, before jump into this, let's understand this one. This is called as a deep learning. Okay. So normal what happened, if you take an example of our learning maturity, how our learning maturity works. So this is a brain. Class 1, class 2, class 3, class 4, class 5, class 6, class 7, 8, 9, 10, 11, and 12. So we go through every class and we learn something new. And once we basically pass the 12, we are in a position to handle anything. Same like in deep learning, these called as the input layers. The more data is passed through this layer, okay, more verified data can be produced. Verified intelligence will be produced. Is it clear? So input layer is receive the input data, like it passes data into a neural network. Example, image pixel, test token, sensor reading and all that. Hidden layer is basically perform the main computation learning. And this has become a drawback also. If you get a question in the exam, the deep learning, this is the deep learning. Okay, the biggest concern in deep learning is this black box. How they connect, how they correlate, okay, because it does not see directly as a final output. So they have their internal logic. The biggest concern is basically is the biggest concern is basically no visibility. There's an exam question also. Okay, neural network. Okay. So neurons are the basic processing. More neurons mean more visibility, more effectiveness of the data. Each neuron receive input from the previous layer and it applies the mathematical operation. So simple logic is that more neuron, more intelligence. Less neuron, less intelligence. The same happen in our, so it's act like a human brain only. So input layer get the data, hidden layer does the learning, output layer provide the result. More data, better learning. That is why in this we called as the algorithm. Algorithm are the foundation for machine learning. And security professionals must understand algorithm to assess the AI related risk. And algorithm help the AI system to learn from data, identify pattern, make the predictions. And role of algorithm in AI is basically act as a building block. It actually guide how the model learn from training data. It help the model to improve the performance of the time. And more important, the different algorithm use different tasks. That's something we have. But question is, how do you tune the algorithm? That is where we need to understand another part which is testable in the exam, which is basically called as a hyperparameter. Let's understand. So before I jump into the hyperparameter, we already discussed algorithm, which is a step-by-step method used by AI ML model to solve the problem. Okay. And algorithm is like a learning method or logic. For example, email spam detection. So algorithm learn the pattern such as free price, urgent claim, And based on that, we already covered linear regression, logistics, and all that. So algorithm tell the model how to learn. Okay. But hyperparameter is a setting we have to choose before we training that control how the algorithm learn. This is an exam question also. Hyperparameter is all about what is the level of learning. It's called as a learning settings. Okay. Like what should be the learning rate, the number of layers, the depth of decisions, the number of neighbors, number of clusters. So hyperparameter control the learning process. So in more layman term, when we say algorithm is a method used to learn. Okay. But hyperparameter is a setting that control the method. This is the exam question when we need to set this. So algorithm is like a recipe. Boil water, add tea, add milk, add sugar. Hyperparameter adjust the settings. How much sugar, how much time take to boil, how much milk is required. So algorithm talk about how the model need to learn, and hyperparameters setting the control how it learn. Is it clear? When I was preparing for the AISM and all that, I was struggling on this. So when you're talking about why this is important, because choosing a right parameter can be important to choose a right algorithm. So poor hyperparameter selection can lead to lower accuracy, overfitting, underfitting, slow training, and all that. What is this overfitting? We're going to discuss in my next slide. Okay, it's very, very important. So underfittings and overfitting is very important. So algorithm is a learning method. Hyperparameter is a learning setting. Model is called as a trained result. A good algorithm come with a good hyperparameter, good data, which equal to the better AI performance. Okay, that's something we need to understand. So whenever you opt for any AI, okay, we need to consider several factors. Okay, the first factor is the LLM. LLM stand for large language model. So AI system, trained on vast amount of data, right? So they use a neural network architecture called transformer, which look for the pattern. It was introduced in 2018. Otherwise, previously they take one word and based on that produce the output. But transformer, what they do, they look for the patterns and based on that generate a response. So LLM is large language trained model that understands generate a language. Second is what kind of a prompt you're going to enter, because your input is defined your output. So instruction given to AI, better prompt is better output. The third most important part is called as a foundation model, because normally in India and all that, you first take a foundation model and then you train data on that, llama and all that. So it is a large general purpose AI model. It can be adapted to many tasks. So good to have a foundation model, then you trained. That's why whenever you go to learn anything, you should unlearn yourself. That's a foundation. Okay. Transformer is basically introduced in 2018. And it play a very important role in LLM because it look for the correlations and connect the dots. Is it clear? Initially what happened, AI pick every object as an individual entity and based on that do the analysis. But transformer is basically focus on the patterns. Okay, they give attention. Okay, the keyword talking Prabh is CISSP, Prabh is CCSP, Prabh. So is a transform attention. So when you're giving more attention, it can able to provide the great output. Then we have a NLP. We already discussed that. It's also very important how the AI is going to react. What is the sentimental analysis? How the hyperparameter was adjusted in the model for sentiment analysis. That is very important. Is it clear? Especially when you're building an AI system for EU, you need to be comply with the EU AI Act and all the sentimental analysis is very important. Underfitting, overfitting, I'm going to discuss in my next section. And this is very important because underfitting basically mean model has not learned enough. It is too simple, failed to understand the real pattern. So let's example, students study only 2 pages for the whole syllabus. Okay. Result is poor mark in the practice test, poor mark in the final exam, right? Because student did not learn enough. So AI model is trained on a detect spam email, but it only check one word like free. So it missed many spam. So training data performance is poor. New test data performance is poor. So underfitting basically mean model learned too little. Overfitting is basically model has memorized the training data too much. It performed very well on training data but failed on a new data. Because if you ask me, I went with who is your best friend, so you need to write an essay on that. So I learned everything about who is your best friend, but in the exam I got a essay on father. So it performed very well on the training data but failed on a new world data. Or let's say example, you memorize the entire question paper, result excellent mark on the old paper, but more mark will be on the actual exam because student has memorized the old, right? Or let's take example, AI fraud detection model memorize the old fraud pattern. So it will not able to detect the new. So overfitting is basically mean model memorize too much. Is it clear? So we're going to discuss about that. And nowadays what happened, we also offer AI as a services, which is basically providing you cloud-based dependencies, cloud-based entire AI as a function. But problem is that everything you have to depend upon the AI vendor. So I want to give more time on the underfitting and overfitting. So as I said, underfitting is happen when model is too simple, performance is poor in both training data, test data, and produce the inaccurate, weak predictions. It is too basic, not enough training. It can bypass the new attacks and all that. But overfitting is basically happen when model learn the training data too precisely. It memorize the noise, error, outlier. It perform well on training data, but poorly on the new data. So common causes too complex, poor validations and all that. Okay, so as I said, underfitting is a weak prediction, but overfitting failed in a real world situation. Is it clear? So overfitting, training data was excellent, but new data is unpredictable. So how to fix? If you want to fix the underfitting, okay, use better model, add more useful feature, train longer, improve data quality, and reduce excessive simplification. And how to fix overfitting? You can use more diverse word, because overfitting can lead to the biasness also. This is an exam question, because you trained on a one particular set of data, right? So and if you going to use new data according to it's not relevant. So the biggest concern with overfitting is basically biasness. So we need to simplify the model, remove the noise, validate the separate data, and stop training before memorization. So if the question talking on model perform poorly on training data, is data underfitting. Model perform very well on training data but poorly on new data, overfitting. Model is too simple to capture pattern, is underfitting. Model memorize noise, outlier, overfitting. Model does not generalize to real world, overfitting. So that's something is basically we need to understand. Okay, so next topic is called as a AI security architecture and design. See, one thing we need to understand whenever we're talking about design function, or when we're building any kind of a AI solution, we need to first design the entire stuff, and we need some components in that. And the purpose of having an AI security architecture is depend upon how the organization develop and provide the user AI system. And it is always coming with the right control, because right control cannot select until the enterprise understand its role. So AI architecture address the model type, what kind of a model we are using, because model is the brain of AI. Trial and test model governance is there. What kind of a data we're going to feed on the model. We have to make sure the source, privacy. I'm going to discuss the section in detail in my further slide. Make sure the right environment is required in which I'm going to run the AI models. We need to be comply with the legal regulatory requirements like GDPR, PIPDA, DPDPA. We also need to evaluate the business risk and make sure you should able to have an ethical responsibility in everything. So when you're designing an architecture, we have to consider all these dimensions when you plan your solution. That's why there is one concept called as a AI secure by design. Because if you introduce security in the later stage, it will be more expensive. So secure by design means security is built in technology from the beginning. Because if we introduce security in the later stage, it will be more expensive. And the goal is very simple. When you're building an AI system, protect the device, data, system from unauthorized access. So the question is, how can I introduce security in the design stage? So during a design, we do threat modeling. During a development, we do secure code review, model integrations and all that. During a deployment time, make sure we should have a secure environment in which I can deploy, run as per the business objective, maintenance should be there, and last but not the least, end of life. So that's something we have to look for. When we're talking about AI security functions, AI system should not be secure after the deployment. It will be more expensive. Security should be considered while designing, like during an architecture, adding an AI angle, data pipeline. When you're collecting data, source of data, make sure you should have a proper security. Training data sets should have a proper integrity. During a model development, adding a security, integration, and governance process. So security by design mean AI security built from the beginning. And when you talk about AI security, you must cover both AI use in a development and AI system being developed. So both security we have to check. So during a development, how we adding a security, and if we developed it further, how can we add a security? So governance, transparency, accountability, secure infrastructure, life cycle control are essential for a AI secure element. Okay. So before we talking about AI secure by design, one thing we need to understand, what are the different type of roles mapped with the AI security architecture. So because before applying AI security control, we need to first understand what is my role. Are we supplying the AI? Are we building the AI, or are we using the AI? Because security responsibility change based on the role. So first is called as a AI provider. AI provider is the organization that provide AI products, platform or service to other. Example like OpenAI, Microsoft, Google, they provide AI chatbots or AI platform to the customer. And when it comes to security part, the provider must ensure the AI platform must be secure. The model's infrastructure must be protected, the service will be reliable, and the security documentation must be available. So if the question documents apply AI service or platform, answer is AI provider. Now second is called as a AI producer. It means the team that design, develop, test and deploy the AI products. Let's say example, there's a bank. They're building a AI fraud detection model. So bank data team will collect the data, train the models, check the bias, deploy the model, monitor the performance. So producer must ensure the training data must be secure, model design, source code, API. So they are the one who build and develop the AI. Third is basically called as a AI customer. We as a people. So bank use third-party AI chatbot for customer support, or user using a bank chatbot for the interaction. So bank did not build here, it used in a business. So that is basically called as a AI customer. One of the limited control, one of the limited controls, limited governance we can see in the AI customer. More control in AI provider, less control in AI customer. So customer must ensure the AI used for approved purpose, the user are trained, the sensitive data is not exposed and all that. So cloud vendor is the AI provider. Bank AI team or vendor team, they customize the chatbot logics, they are the AI producer. AI customer bank using a chatbot for customer support, that is basically called as a AI customer. So before implementing AI, the security team must check what kind of a models we have. Okay, this is the exam question, because model is basically all about the kind of AI being used. So LLM, fraud model, recommendation model. So LLM risk is different from facial recognition risk. Second is the data source. What data is used? Where the data coming from? Is it personal, confidential, regulated? Third is called as a most important part is legal and privacy obligation. Where the data, does the AI use personal data? Is consent is required? And last is called as a business risk. What happen if the AI give a wrong answer? Can this damage? Okay, is it fair? Is it biased? Is it transparent? So that's something we have. So provider supply AI is AI provider. Producer build AI is the AI producer. Customer use AI is basically AI customer. So model plus data plus legal plus business risk plus ethics has to be considered when you're building an AI architecture. That's a very important part we need to understand. So now the question is how we can see AI security angle. It means we need to secure the AI, right? So I'm using AI to support the development. So we have to make sure we have a secure coding assistant, because code generation tool, vulnerability scanning for scanning AI code, that we have to look for. So we also have a AI driven security analysis where we using AI for a threat detection, log analysis and all that. So here I'm talking about AI security. It means I'm using AI to secure. I'm using a AI tool for a secure coding. I'm using AI tool for detecting threat. I'm using AI for log analysis. Okay. So one thing we need to look for is how you're developing, or let's say example, you're developing your new AI solution. So we have to make sure the right training data should be there. You design the model, you test the model. That something is part of a requirement. And when you talking about the secure by design, right? Data storage, proper pipeline, model representative, development environment, CI/CD pipeline, that need to be there. And everything is possible with the right governance. And right governance basically start with documentation of all the things. Second is communicate all the things, implement in a proper manner, review regularly, and more important, improve over the time. So these things are there. Now, one more important thing you need to understand when you're talking about AI secure by design, you need to first understand the customer expectation. You're dealing with AI in Europe. Okay, EU basically have their own AI Act and GDPR. You're dealing with AI in India. You're dealing with AI in UAE. Different country has a different context. So you need to understand what is their perspective. Do not push security responsibility only to customer. Okay, so you need to have a proper consent management for the data set you have, secure data pipeline, protect customer data, and secure model access. Is it clear? So that's why we say design the model, develop, deploy, operate, monitor, retire, and security you will run parallel in all the phases. Now, when you're building this AI model, the most important part is transparency, accountability. You should give a complete clarity to the customer how you basically come with this decision. What is the source you have used for the outcome? And if you're doing any mistake, take the accountability for that. So you need to have a proper explainability in the AI decisions, document the model behavior, clear the system limitation, audit trails and all that, because that build the trust. Remember one thing, transparency and accountability is the biggest factor in building a trust within a customer. Is it clear? And third, the governance leadership. You need to form the committee, set up the clear roles, management oversight and all that. Along with that, we are using AI security. Is not something replacing a DevSecOps. We are using AI in DevSecOps to faster the process. So we're just extending security into data, model, prompt, and pipeline because we are integrating data. And so when you're talking about infrastructure in which we're building an AI and all that, make sure you should have a secure storage, establish the document process for AI function. And the most important part is communicate the things regularly and review properly. That's something we have to look for. Now let's take an example. You are designing an architecture. Fine. Everything is depending upon data. Data is a new oil. Everything depending upon data. If you have a right data, it can produce right output. So most important part, if I'm building my AI system and in that I'm feeding a data, the most important part is data source. Data source is very important. Format of data is very important. Quality is very important. Is it clear? We have to document the model inputs. We need to ensure the production data match the training data expectations. The biggest concern is when you feed data in the AI model, we need to feed the right data. During that time, if attacker feed any kind of a poison data and all that, it can learn the poison information. So that can become a concern. Data poisoning is the biggest concern in training phase. Definitely data is we have to collect. So AI system may create a store and volume of data. We need to identify where the AI inputs, and we need to have a control access to the stored AI data. So example, the key risk is like data leakage, misuse, shadow IT, drift, which is basically lead to the unbiasedness and all the biasness and all that, and weak access control. So we need to make sure we should have a proper security control on the data. Along with that, we need to also talk about the configuration management. If you're talking about the traditional configuration management, we talk about the uniformity of the system configuration. Example, we have a system A, we have a system B, we have a system C. All three are running with same configuration. In the case of AI, we're talking about model configuration, model parameters, tokenizations. Okay, so we need to make sure the same data to be trained in all the models. And any kind of a changes are there, it need to go through a change management process. Another important thing, how do you select the model? So AI model selection is also very important. So we basically look for the most important part is inference settings. So when I say about inference settings, okay, as I said, model is the most important part of AI. Now question is, what should be the factor based on which we select the model? You should select the model which align with the business need, risk, compliance, and ethics. This is the exam question also, because when you're designing an AI architecture, you must think beyond your normal IT security. You must control the models and setting and the external impact. So as I said, AI model, you should choose how the AI will behave, what type of output will produce. And that is always should be aligned with the business need, risk and compliance ethics. So this is the exam question. So choosing a right model for the right business purpose and risk level should be there. Now, one more important thing, we talk about the versions. If you change the AI model or you upgrade to a new version, the output may change, right? Let's say example, a company use AI model for loan approval. After upgrading a model, earlier it used to approve the certain customer. Now it rejects similar customer. So you need to check how do you change the model, because model change lead to the output change risk. Okay. Now what is inference settings? Inference setting is all about how the AI respond to the runtime. So one common setting is low temperature, and one is basically called as a high temperature. Low temperature is basically mean more consistent. And one more important thing we talk about is this one, implementation. Okay, so more consistent and predictable answer. And high temperature is basically more creative and vary answer. Is it clear? So let's take example. For legal and compliance, use low temperature because accuracy, consistency matter. For marketing slogan, high temperature may be excelled because creative matter. So temperature may affect the creativity, consistency. And as I said, model choice must be aligned with the business need, compliance requirement and all that. Second part is regulatory. Make sure your model should be comply with the regulations, because you should not introduce any AI which can affect the job, trust and fairness, because it is, if you take example of EU AI Act, it is part of a banning. So architecture must control the data storage, configuration model, regulatory impact. That's something we need to have. Now let's take an example. You want to introduce some changes. Okay, you want to introduce some changes. I do understand. Okay, so there is a possibility you will introduce some changes. So it need to go through a change management process. The way you're doing a changes for the traditional IT and all that, similar kind of a change management we have to follow here. So if AI security architecture change, the change management must update the risk considerations. And the reason of introducing a change management process, because it use a risk assessment process for the change management and it track the accountability. Now, how can we introduce a change? So AI change plan only successful if it support the business goal, one condition. Second, it reduce the risk, and more important, align with the organization security. That is the only condition the change will be successful. So we need to include how it affect the stakeholder, technical integration, using a compensating control. Change can track the model creations, model provenance, which is the most important part. What is model provenance? Basically talk about the source of model, purpose of the model. We need to review how the AI change affect the BCP and recovery, because we need to have a contingency plan and make sure you should have a rollback plan and all that. So this is basically part, you can say, of the A. Now we move into the part B, which is called as a AI lifecycle. So next is called as a AI lifecycle. Part B. We already discussed about the basic of security architecture. Now we are moving to the AI lifecycle. We have learned in CISSP, CISM, talk about SDLC, software development lifecycle, right? Similar, we have a AI lifecycle, building a AI from scratch. But make sure there will be a question can be asked in the exam is in which particular stage you introduce a risk assessment. Risk assessment, security by design, should be introduced as early as possible. And make sure risk has to be reviewed in every phase. What is the lifecycle? I will show you in the later slide. Okay. Different AI actor may see the different risk in the AI lifecycle. Developers see risk from a coding perspective, deployers see from environment, providers see from user, and customer will see from different perspective. But make sure every role need to have a clarity, because all AI actors share the responsibility of building a trustworthy AI fit for the purpose of AI system. So according to OECD, AI lifecycle basically have a phases. Okay, the phase 1 is plan and design. Phase 2 is collect and process data. Third, build and monitor, test and evaluate, make available for use and deploy, operate and monitor, retire, decommission. And we're going to discuss each and every step in detail, because in the exam, they might ask you what happened in every phase. And if you are a person who preparing for this exam, you need to have a very good understanding of test, evaluate, verify, and operate and monitor. And as I said, we're going to cover each and every section in detail. So first is called as a plan and design. Before we build any kind of a AI system, we need a clarity why we need AI, how we're going to use AI. And that is the reason we need to define the AI system concept, purpose and objective. A good design should include the purpose and objective. So let's say example, you are a customer. You are interacting with the vendor. Okay, so customer share his requirement. Based on that only, you're going to build the system. So you need to document all the assumptions, context, requirement, intended use. Also, you need to define the success metrics before the development begin, how the AI product look like. It is good that you involved in this stage a customer, because you get some understanding here, and you need to establish the leadership, accountability, and decision making. And make sure when you're building this, identify all the legal risk and everything. And you create an initial risk assessment for a proposed AI use case. Once you plan and design, based on that, you need to collect the data, because based on the right AI system, we need to collect the right data. And it is the most important stage. So data quality directly affect the AI accuracy, reliability, trustworthiness. This is the primary factor which affect if we don't collect the right data. And if you have a poor data, it can primarily impact the inaccuracy, biasness, and non-compliant. Any question in the exam talking about inaccuracy, biasness, answer is because of poor data. What is the primary factor when you're collecting a peer data? Make sure you should take a consent so that you can be comply with privacy regulation requirement and all that. And make sure, check whether data is complete, relevant for the business case. That's why we need to maintain the data provenance documentation. Data provenance documentation means what is the source from where you collected this data and all that. Because tomorrow, if your organization face any kind of a data privacy regulation audits and all that, you should know, you should have a complete information. What is the source from which you got this data? Now, based on the data, the next step is build the model from scratch, a foundation, or you can adapt from market. This is the most important phase because this is the phase where you fine tune your model for AI prediction, decision, or insight. Now the question is, how can you select the right model? You select the right model based on a business objective. That should be your primary. Second is type of data, what problem you're going to solve, and what is the expected outcome. So you have to train the model using a data. You need to calibrate the model, which is called fine tuning and all that, to make it more accurate. The primary reason to fine tune so you can have a better accuracy and performance. Test and adjust the model through the repeat iterations. That is normal practice we have, and we need to identify the variables. That something is part of the build and adapt model. Then make sure for every critical decision, human oversight is required. So any question in the exam talking about what is the most important factor for critical AI decision, human in the loop is required. And we use human review to improve the accuracy, robustness, security, and ethical use. And make sure we should record everything. That something is part of the function. Now the next is, once you deploy the model, you need to test that. Test basically check whether the control is working or not. So you ensure that it should be accurate, effective, trustworthy, secure, fit for intended use. Is it clear? So testing is basically check how the model perform under different condition. We evaluate the result, we verify whether it's working as per the business objective, and we validate whether it met the business objective. I repeat again, the difference between the verification and validation. Verification is done against the documented requirement. Is it working as per what we documented in a phase 1? But is it really working as per the business objective? That is basically called as a validation. So you adversarial testing, pen testing, prompt injection, we do in a validation only, because we have to make sure it should produce a relevant output with the right data, and that I'm going to cover in detail. So this is a very important part. Okay, when we talking about testing is include multiple factors. First, we're doing a model testing. Model testing basically check whether AI model is performing properly against the expected standard, or you mean to say that it is basically checking whether model is giving a correct and reliable result. The question is, what is the parameter? First, we basically check the accuracy. Now, what is accuracy? How often the model is correct? Okay, so accuracy, answer how model is correct. That's the first thing. Second, we talk about the precision. Precision means when the model says something is positive, how often it is actually correct. Third is called recall. How many real positive cases the model successfully catches. And we have other metrics like F1 score, false positive, and all that. So let's take an example. Okay, so we are using a spam detection model. Okay, so we're using a spam detection model. How many email did it classify correctly? That is accuracy. When it says spam, is it really spam? Percentage is precision. Did it catch most of the actual spam mail? That is basically called as a recall. So model testing, check whether AI performance expected. Next is basically called as a stress testing. Stress testing basically check how the AI behave under different unusual unexpected outcome. Will the model still behave properly when the situation is not normal? So we test for the strange input, edge cases, adversarial manipulated input, and all that. Third is basically called as a comparative analysis. Comparative analysis means comparing a new model with the existing model. Benchmark. Example, new model versus old, new model versus industry benchmark, and all that. That's something we have. Last is basically called as a bias and fairness, which is the most important for check the discriminations and all that. And finally, we have a scenario which we creating a test cases, and based on that, we do the testing. So ultimate goal is basically it ensure the AI system is accurate, trustworthy, secure, fit for intended use. Now, one activity we have to do is red teaming. Now, what is red teaming? Red teaming doesn't follow any scope. The difference between the pen testing and red teaming, pen testing come with a scope that I want to test this infrastructure with this IP and all that. Red teaming is not come with any scope. Their scope is not fixed. If they got a AI model and they want to test, they will do everything to test the AI model. So they actually simulate the real adversary techniques to identify the model behavior. And by doing this, they can identify the risk, blind spot, misuse, model limitations, and all that. So red team should cover base model, how base model can be misused, what the model can and cannot, and limitations behavior. And application level is basically which is connected with them. Can I able to inject any kind of a queries and all that from there? So let's take example. This is basically the interface we have. This interface is the application, and the backend is basically the model. So what kind of a value I can enter in this application? So that is called as application level testing. And how it impacts the change in the model. In my domain 2, we discuss about model poisoning, model inversion. That is called as a base model testing. So testing should follow the organization change management process. Lesson from testing should be fixed. If risk is found, we need to document the mitigation, document the risk register. And once it is basically validated, then it moves to the production. Now we're done with the testing. Now it's time to deploy the model in the production. So here we're talking about test environment should be identical to production environment. Be done successfully. Now it's time to move the model into the production. We move AI solution as per the approved plan, pilot in the control environment, regulatory compliance, check the compatibility. The biggest concern is compatibility has to be checked. Train the user on new roles and monitor the user experience and everything. Now we have deployed that model. Okay. Now we need to use regularly. So this is basically we have an operation which is day-to-day activity of the model. So maintain the metrics, track the accuracy, because once you deploy, if you don't monitor, what if the model get drift? It will not able to learn the new data. So we have to do the regular monitoring. We look for the quality management. We have to verify the regulatory compliance, industry standard, compliance mapping. So monitoring is very important because that helps you to build the trust. When model is not in use, we have to destroy, we have to discontinue. Is it clear? So retire AI when it's no longer meet the intended purpose, return triggered by the outdated technology, better alternative, non-compliance, business change, and all that. So we need to create a formal decommissioning plan. This is the exam question. You want to discontinue the model. What is the first step? Decommission the plan. Use the organization change management process. Your plan should include the data migration, data deletion, system reveal, integrate cleanups, and continuous operation. And then you communicate all those things to the parties. So this is a very important part. Now we are moving to the part C, which is called data management controls. So part C is called data management and controls. So when you're talking about data governance is the most important foundation for AI governance. I'll tell you why. Because if you don't have right data, it can impact the quality of the AI. So data governance ensures the data which is used to train, used to test, used to operate, it must be trustworthy, it must be lawful, it should have a high quality, and make sure it should fit for the purpose. If you take example of existing governance, we have, collection, process, store, use, monitor, retain. But one thing is basically is why we are collecting data, and data governance is basically answer that question, why we are collecting data, because data governance is all about managing a data. So AI need a specialized data controls, but baseline governance principles still apply. So we will go with the basic encryptions and all that. But on top of it, you need to define your own controls. Governance basically ensure the AI data lifecycle activity are controlled and, more important, accountable. If you're collecting data, make sure you should have a proper tracking of the data, which is called data provenance. Okay, data lineage. Because if you have a strong data governance, you can have a control over the data ownership, quality, privacy, security, and proper use. Now, when we're talking about data governance practice, we have a four-step process: data acquisition, data organization preparation, data utilization, and data retention. And we're going to discuss everything. So first step is called data acquisition. Everything, the data governance start with collecting right set of data. Make sure when you're collecting data, it should have document the origin and legal base, which is called consent, especially when you're collecting a PI data. Data acquisition should be supported by a data processing agreement. If you're collecting from third party, you should have a proper SOP, which gives the conformity, uniformity, purchase documentation, approved data receipt process, and security team should ask where the data come from, which is basically called as a data provenance. One more important thing, we need to ask ourselves, the data that I'm using in model, is it consent is there? Okay, can be used for AI training. Is the privacy ethical section has been documented? And make sure you should basically collect all the parameters properly, because your data volume, possession period, and process frequency affect not only storage but also security decision. Why? Because if you have old data and all that, it can lead to the wrong decision. So that is very important. So data acquisition is the most important step in the data governance. Now, next step, once you collect the data, you need to clean the data, prepare the data and all that. Is it clear? So all AI data must be organized. If you don't organize that, it will unnecessarily take more effort. It should be mapped, it should be secure, and make sure it should be clearly documented. So AI data processing should receive the same security review as the enterprise data process. So each AI process should have a clear data flow mapping, processing assets, storage locations, ownership, and access control, which is part of a requirement. So we have some important security control in this step is like data flow mapping. It's very important. How do you collect the data? Okay, are you keeping the data on-prem, cloud, or hybrid? So in this entire process, data inventory is a very important because it supports the incident response, evidence collection, and all that. If AI training changes or impact data, the data element must be known to be monitored. And make sure whatever the data we collect, we should give the access to the specific person. Is it clear? So we need to apply least privilege to training data sets, testing data sets, AI model storage environment. So we need to have a principle of least privilege, necessary right assigned to the user, not many, not less. That's something we need to have. Along with that, we need to have a data integrity monitoring. It means collect only relevant data, because if more data we collect, more accountability comes to us. But less data you collect impact the AI decision. So make sure you should have monitor data minimization, cleansing the data. Now, when we're talking about cleansing and all that, it's like a normalization, structure it, so you can make it standardized. So data steward should be document how data is changed, because he is the person who ensures the quality and governance of the data. We also need to track the manipulations, transformation, pre-processing step before we feed the data in the AI model. So we have some controls like data sharing agreement should be there. If you're collecting data from a specific agencies, when data is not in use, secure delete the data. Risk management, when you're importing the external data. CIA requirement, we have to see if you're into healthcare, confidentiality is important. If you're working in the e-commerce, integrity is important. So we need to see the CIA requirement and conduct the risk assessment before processing data. Good practice is always before. During and after we can do, but it should be done before. Now, next step is basically called as the data utilization and storage. So AI data depend on the type of agreement we discussed, processing also. So we are using development deployment, so we use the data. So one of the things we need to ensure when you're feeding a data is you have to follow the privacy by design. Privacy by design basically mean introducing a privacy from a design stage. We need to introduce a privacy control, remove the identifier. So we use pseudonymization. In pseudonymization, what happens is name is replaced with some ID. All the generated data should have approval. It should not be hallucinated. Make sure we should have a proper control what information going outside, inside, threat environment, business mission, risk tolerance. Risk tolerance is the biggest factor in deciding how the data flow happen, because risk tolerance drive the controls and everything. Then data sensitivity and approved use. Along with that, all data storage, AI data storage, it should have a proper controls. We need to have an encryption, data at rest, data in transit, and data in use. And based on a classification only, we can map the data. Now, when data is not in use, we have to retain for some time, and after that we have to destroy. Now, when you're dealing with retention, availability and integrity is the most important part, because tomorrow if I want back, the data must be available. It should be available in the same state. So retention schedule must cover your data used by AI for how long, data generated by AI, how long we have to retain, temporary data, log data. So stored AI data must have a clear business, legal, operation reason for retention. Primary, we follow legal requirement, okay. And make sure access to stored AI data should be reviewed regularly. And that's something we have to do. And when you want to destroy, it should be destroy according to the organization retention schedule. This is an exam question. What is the primary factor based on which we should destroy the data? It should be based on the organization retention schedule. Second is destruction should be documented, because we should know what is the approved procedure we have. And before deleting any data, we have to check all the metrics. And if it's using for AI gen data, may require the evidence for investigation. That something is part of a requirement. But we also follow some governance requirement, like, it should be involved a different governance structure, a committee of people. Security by design principle should be there to make sure it should not be accessible to anyone. One biggest concern is that if you train the data, if you train the model and the model is running behind the deep learning and all that, it is always a challenge. This is an exam question. Okay, so in deep learning system, the biggest concern from data point of view is data creation, deletion may not be always transparent, and lack of visibility can affect the integrity and create a hidden risk. So that is basically the biggest concern when it comes to the deep learning and all that. So AI is definitely depend on data, but data security is critical to protect the AI organization. So we have to make sure that we should protect the personal data, financial data, and data security control should be evaluated across the complete life cycle. That's something we have to have. So the question is now, what should be the decision? So AI require large volume data for training, also testing, operation. Okay, now let's take example. You are introducing an AI system in India. You cannot export data from other countries. You have to use the India data only. Let's say example. So we have to look for the regulations such as privacy law, data residency law. Data residency law, what is data residency? So let's say example, this is the company A. They are based out in India. They're doing a business in India. So they have to keep the data in India itself. That's called data residency. Because data is now in India, default law will be applicable as per the India norms. Now they have a customer in US. They have a GCC in India, but they move data to India. This is US, but they moved data to India. So data location is basically India, but sovereignty, residency law or sovereignty law, they will apply as per the US law, GDPR law. So it's very important. You need to understand that, okay, data residency play a very important role. You cannot move data outside the country. We need to take an approvals and all that. And when board may push the AI adoption, the CIO, CISO must balance access of the production with business units and all that. So greater data access increase the risk of intentional data exfiltration, accidental leakage, misuse of representative data, and compliance violation. So least privilege must apply to the system, identity and applicable. So in the worst case, even it is basically hack, the impact is basically limited. So AI need data access, but security need to maintain a different kind of a metrics and all that. So before we jump into the core AI, we need to first understand data encoding. Okay. So what happened? Data was trained on a raw data. So raw data is the original data before the AI model can understand it. Example, I will mention here is I love Prabh. Okay, if you watch the video till last, you can also type in comment. It give me a very good visibility. Just get an example. So this is a raw data. Okay, raw data is the original data before the AI model can understand it. Okay. Now here, image I called as a pixel. Okay. Audio is like a sound wave. Okay. And logs are called as a raw security event. Okay. So AI model cannot directly understand this like a human. The data must be converted into the machine friendly format. And this is where we introduce the tokenize. Okay, so tokenization mean breaking the raw data into smaller piece so AI model can process it. How? So here we have I love Prabh, right? So I will be one token, love will be one token, and Prabh is one token. So after tokenization, it's like that. Or I love PR, or so each token is then converted into number because model work with number, not words. So tokenization convert the human readable data into the model readable piece. So why does you can say deep learning? Why does deep learning need tokenized data? Deep learning model needs structured numeric input. Okay, so when I say this way, raw image, audio, and logs. Okay, so it is basically converted into tokenization. Okay, the tokenization map to number, vector, binary files, and then the model is being trained. So model learn the pattern, okay, from this process number. Okay, so what are these record? TFR .ckpt.ph. So when I say TFR record is a TensorFlow format which is used to store the processing training data. CKPT or checkpoint file store the model training progress. And .pth is a PyTorch file often used to store the model weight or trained model data. So these files contain the process data, model learning process, model weight, and the training data sets we have. I repeat again, TFR is used to store processed training data. CKPT is a checkpoint file that store the model training progress. And PTH is a PyTorch file often used to store model weights or trained model data. Now, why should tokenized data must be protected? Because if data is tokenized or in binary format, it is safe. Okay. Even if data is converted in token binary, it may be still contain sensitive information, right? So we need to make sure we should have a proper protection. That's why we have access control. Only authorized users should have access to training data. Encryption, protect the file at the rest during a transfer. Secure storage, secure your AI artifacts, which is approved, and protect repositories, and make sure we should track who access, copied, and everything. So tokenized data is a process data, not a risk-free data. And protected tokens, embedded systems, checkpoints, these are basically the practice we are using for the function. Okay. Now, as I said, data may be converted to vector. We discuss embedding are a mathematical representation of text, image, audio. Okay. And GenAI and semantic search often use a vector database. So vector database must be secure with access control, encryption, index level, and all that. That's something is part of a requirement. So overall data access, whatever we have, all data is often collected from multiple sources. If you have aggregate data into one place, the biggest concern is called as a data lake, which is called increased because we have aggregate data from multiple sources. And the centralized data become a high value target for attackers. So data transfer from source system to target system may weaken the original control. So make sure we have to look for the data exploration data scientists, which talk about the purpose and all that. So we have to review all the AI data flow properly to identify the system, store, use, access path, and ensure the access control remain consistent for a source to target system, and review the network policies and everything, which is actually the most important practice we have for the function. Now the next part is called data confidentiality and secrecy. See, let's take example, if it's a encrypted data, and if I feed this data in the model will not able to learn anything from there, right? So because model going to use this data and update the model, this is basically called data in use stage. Data at rest, data in transit, we can encrypt, but data in use, no encryption. Okay, so we have to use a pseudonymization. So example, Prabh is AAISM, CISSP. 1112 is AAISM and CISSP. So name is replaced with the identifier. So they're now going to call me based on this. So even this data is disclosed, it will not link to the any individual. So this is called a pseudonymization, which is used in GDPR. So whenever we want to train the model, we have to look for an opposite of encryption, because if you use encrypted data, model cannot learn from that. So make sure the sensitive data may be decrypted during a AI processing, but this can weaken the confidentiality if you're not controlled properly. So key risk is expose of personal data, IP leakage, weaker protections, and all that. So one of the possible controls is limit access to the unencrypted production data, monitor sensitive data, apply disk level encryption, use strong access control. And one more important thing we can use is privacy preserving tech. So before I jump into the privacy tech high level, I need to discuss about more in detail about the different type of privacy preserving technique. Okay, so I want to take one slide here. So as we discuss anonymization, where we're removing a personal identifier, so person cannot be identified. So let's say example, when you book Uber, Your number is replaced with some temporary number, but that is only valid for that session. Once the session is over, it's gone. So we cannot able to link back. But when the person go to hospital and all that, your name is replaced with permanent with patient ID. And then in the entire hospital, they call you by the patient number. That's called a pseudonymization, where they replace real identity with a fake ID. Is that clear? So identity hidden, not removed. Then we are using new concept called differential privacy, where we adding a more noise to data. So it is difficult for the people to identify it's a real data or not. So reports say around 10,000 users instead of exposing exact individual data. So we are using this to train the model. Now there's a new concept was also introduced, federated learning, where the model learn from data without moving the raw data to central locations. And you will see soon in India also, like a lot of banking sector is going to use that. How? So we have a bank 1 in Delhi. We have a bank 2 in Bangalore. We have a bank 3 in Hyderabad, and we have a bank 4 in Mumbai. So if we have a central location, we have to feed all the data to one model? No. So model get trained local here on the data, and output of the variables go to the central location. So by this way, we manage the data security also. The model was also trained. That is called as a federated learning. Okay, where the model learn from data without moving raw data to central location. Okay. Next is called as a homomorphic encryption. Homomorphic encryption basically mean allow the processing while data remain encrypted. So what happened is, this is the black box we have, and the black box has a key. So encrypted data go inside the box, the key will decrypt, read the variable, and throw the output. It is like, remember when you are a kid, so this is the room we have. Okay, so you ask mom or dad, I need 100 rupees. So mom will go inside the room, open the almirah, and take the money and come out. So they will not calculate in front of you. The same like homomorphic encryption we have seen in the Google also, which is, I forget the name. So here we have a black box. The key will be in the black box only. We stored that when we process the encrypted data in the black box has a key, decrypt, read the variable, and throw the necessary output. So it will not throw the plain text. It will just throw the output. So data will remain encrypted. We can able to process that. So that is called as a homomorphic encryption. And last is called as a SMPC, which is called secure multi-party computation, where the multiple parties compute jointly without exposing their data. So these are the different type of privacy preserving technique we have. From the AISM perspective, federated learning is testable, homomorphic testing is testable, differential privacy is testable. So summary is that differential privacy add noise, federated learning train locally and send the model output, homomorphic encryption process data in an encrypted state. So homomorphic encryption allow the computation on encrypted data, may support the AI training while preserving a privacy, but one problem is that increased cost, because computation cost is there. So that's something we have to look for. Another important part, we need to look for the data backups. So some training data come from existing source, so backing it up again may be redundant. So AI development create a new artifacts that should be backed up. So we have to take a backup of different data, like process data for training, tokenized training data, model weight. So we have to look for all those metrics. Is it clear? We have to look for all the metrics. Okay, model parameter, configuration file, training data sets, bias testing results. So we have to collect all this data, because if you don't collect, there is a problem. So make sure we should preserve the data, because if we preserve the data, it is easy for you to explain the things. You can reproduce, you can able to audit, and able to provide the investigations and all that. So you should back up the AI artifacts, not only raw data, and preserve all the data sets, weight, architect test results, because it is very important for your AI system. The next is basically called as a data integrity. So integrity of training data and the model is very critical, because by end of the day, you rely on that. So compromised data or model component can change the AI behavior. So we have some integrity risk. Let's say example, training data can be manipulated. Embedded tampering is there, model weight tampering. If we have a model weight tampering, it can give a preference to other. Error during pre-processing, okay, ETL logics, and poison data sets lead to data poisoning. So we have to make sure we should properly validate the training data, monitor for anomalies. If we find any kind of a suspicious activity and all that, we should able to track that. Along with that, document all the test ETL logics, that something is part of the function. Then we document the pre-processing, how you collect the data, what is the way to process data and all that. That something is part of a requirement. monitor the model changes, and any kind of a change we have, it need to go through a change management process, and make sure use the model assembles where it's appropriate. Okay, so that's something is part of a requirement. See, one thing you need to understand in the AI system is training data and model. So during a training, if you alter anything, it will move the altered data into system and it can impact the decision. Same like if you don't secure the model, then model can lead to the concern. So we have to make sure we should have a proper integrity in all this process, because it is a problem otherwise. One more important thing is that if training data is changed, the model may learn the wrong pattern. If model weight or architecture change, the model may behave differently. If pre-processing has error, the final output can become unreliable. So we have to look for that. Now, one more important thing we have to look here is architecture modification. Architecture modification, where the model structure is basically is changed without approval. Okay. Now, one more important thing about monitor the data sets. We should do about how the data is monitored. Hashing need to be there. So that's something we have to look for. But more important part is you need to monitor the models, you need to monitor data, and more important, you need to monitor the configuration changes. And whatever the changes are there, it should be done as part of the business process. And more important thing is that you need to monitor the overall system. Now, ETL stand for extract, transform, and load. So it is a data processing method which is used to move data from one place to other. So let's say example, you collect the customer data from CRM or Excel database and storage. That is called extract. Then after extracting data, you're going to transform. Transforming, you clean, format, modify data so it become usable. Okay, so that is basically there. And then third is basically called as a load. Put the process data into target system. So collect the data, clean the data, and load the data. If ETL logic is wrong, the AI model may learn from a bad data. So we have to make sure we should have a proper control over there. Then only we can have a better visibility. That's something we have to look for. Now we're moving to the next, which is called part D. Okay guys, so we have a next called part D, which is called privacy, ethical, trust, and safety control. Yeah. It's a very interesting one because AI, if you take an example, I'll give an example of AI from perspective is if you're looking for a secure AI, you need to feed a lot of data, but we need to protect the data. We need to encrypt the data. But in the case of safe AI, it can be biased. But if you're looking for a safe AI, not secure, safe AI, where we need to feed a lot of data, but in that case, data can be compromised. But for us, the preference is basically make the AI more accurate. Now, I want to give you the understanding about AI ethics, privacy. But before that, I want to give you one social norms, which is very important for us to understand. When you're talking about AI, if AI fail or it is misused or it is harmed, it can happen at the 3 level. It can happen on the people level, it can happen on the organization level, or more important, it is happen in the entire ecosystem. So most security people only think about system compromise, data breach. No, but AI governance or AI security governance think broader. Always remember one thing, whenever you're going for the AISM exam, our priority is people safety first. This means how the AI can harm individual, group, or society. I repeat, how the individual, group, and society get affected, because AI may affect the one person, privacy, rights, safety. Example, there's an AI loan system. It can wrongly reject a person because of the biased data. Or there is a AI hiring tool which can reject a candidate from a particular gender, region, age, and group. So here you can see we have an individual level privacy. We have an individual level privacy issue. We have a group level impact. And third is called as societal. Societal is basically mean AI may affect the society level right of access. Example, AI generated misinformation which can influence democratic participation, election campaign, or in education AI system, they may unfairly deny access to the certain students. So when I say harm to people, it's all about right, safety, fairness, opportunity, dignity. Second is called as a harm to the organization. This means AI can damage the organization using or providing the AI system. Let's say example, harm to the organization business operation. If AI system used to use in customer support, it might give a wrong response. It has happened with MACD in 2023 and it create a service disruption. Harm to the organization from monetary impact. Attacker poisoned the AI fraud detection model, which caused the real fraud to pass undetected. AI can also misuse the monetary loss in that case. Third, AI can harm the organization. There's a chatbot who start giving offensive or discriminatory answers. An incident go viral. So harm to the organization mean operations, money, and security reputations. Now we're talking about harm to the ecosystem. Ecosystem mean interconnected system, which include the supply chain, environment, and more important, society. So AI failure in one place can affect many connected parties. For example, third-party AI vendor fail, it impact the multiple banks, hospital, and cloud customers. Just imagine, okay? So if you have a AI system, it is connected with the bank. If AI is down, bank is down, it has a supported services down. Or AI can drive failure, can affect the supply chain market. Okay, AI consume lot of resources, electricity, water. You have seen a lot of news around the area. Data center require a lot of water. So large scale AI training increase energy consumption, environmental impact. So that something is there. So AI primarily for me, the important is should not impact the people, then the organization, and then the ecosystem. So according to that, we need to plan the stuff. So now, as we're talking about this module is focused on privacy. This module focus on secrecy and all that. So it's very important for us to know how this privacy secrecy works. Okay, because I have seen a lot of people face the challenge with privacy integrations and all that. First of all, what is the privacy? Privacy is a set of information deal with individual, and secrecy is a set of information deal with the enterprise. That's why everywhere we can see the word privacy for regulator. Secrecy, trade secrecy, which is used for the enterprise. So AI privacy focus on protecting personal data, which is used in AI. Okay, make sure you should have a proper consent management before using any data, because otherwise it is basically backfire. So AI users must have a clear legal basis such as consent, contractual purpose, and consent must match the specific purpose for which data was used. So if data is reused for AI training or AI new feature and consent has not been taken, it's a problem. So consent is very important when you're dealing with the privacy data. Now, AI basically have a specific privacy risk. Example, AI may reuse the data beyond the original purpose. Let's say example, there is a company. They said they're using your data, okay, for your fraud investigation purpose. But later on, we got to know the same data was used for AI. So it was not used for the particular purpose. Second is the training data may include the personal data without proper consent has been used. That's a biggest concern. Or we have given a third-party AI tool to train PI data, or data was copied from a secure environment, may be exposed in an insecure environment. That's why we say your production environment should be separate from test environment. Or AI developer unintentionally disclose the sensitive information. So that something is a concern. So what is the countermeasure? First of all, define what you need to collect. Your purpose should be clear. To the DPIA, privacy impact assessment, to identify why we are collecting, how we collecting. Let's take example. This is basically a website. And this website is introduced for a webinar purpose. Do I need an email address? Definitely yes. So email address column is required here. Otherwise, they will not able to receive the webinar invite. Do I need a name? Yes. Do I need a house address? No. So here we did the PIA, privacy impact assessment, to identify if we collect this, what is the impact? If I collect that, what is the impact? It is very important in the DPDPA, GDPR, PIMS system. We need to do the PIA. There is a dedicated video I made on that. So PIA basically all about identifying risk associated with the privacy. And this is something we do before we collect the data. How the AI provider going to use my data and all that. So that something is also very important. Is it clear? Because that clarity is also required for the for activities and all that. So data processing agreement cover that particular thing, how the data is going to be used by third party. Because see, one thing you need to understand, this is basically called as a AI provider. Or let's say example, this is AI company. This is you as a customer. You went to the bank using AI using, by now we have one vendor whose AI tool we are using. So if you move data to this, by end of the day, I am the one who answerable to data subject. So this is the bank and this is the AI agent tool. So what I did is, in that case, I use the AI agent But if tomorrow any security breach happen, it is them who are answerable. So that's why in the contract, we need to bring the clause about how you're going to handle the data. In GDPR context, this is called data controller. It is called as a data processor. How the data controller, data processor handle the data, that come under the data processing agreement. That's very important. You need to tag and classify the data, train the staff on approve AI use, and keep the development production environment secure, and make sure if you're doing a testing, keep the both environment identical and monitor the data for the leakage and all that. That's something is very important practice. Now we need to introduce the data privacy handling procedure, because that defines how data is collected, processed, and shared. Why? Because if we don't have a standard process, it can prevent uncontrolled use of personal data. Make sure when you're collecting data, you should encrypt the data. You set the timeline of the data, because if you don't set that, if you set this, you can reduce the risk of data leakage. Prevent first data handling, which is called minimization. So design the AI process so privacy is considered before data is used. So we need to ensure the AI use and align with the privacy law and user expectation. Differential privacy, we already discussed, adding the privacy protection into individual record so it cannot be easily identified by adding a noise and all that. And we can use other PET technologies to support the protect data while still allowing in AI processing. And it can basically balance my privacy and business requirement. As I said earlier, there is a table we have. You can see this. So we are using a differential privacy where we adding the noise. In a distributed model, we are training the data and send the model behavior. Data in an encrypted state, still we can able to process, or where the multiple parties compute together to process the data. So these are the different type of PET technologies we can use to process data in a secure manner. And by this, we can support the privacy, compliance, and trust. So if the question say, what is the technology we can use to balance the privacy, compliance, and trust, answer is PET. If the question basically talking about we have to train data but remove the identifier, no one should be able to identify that. So use differential privacy. Okay. Define the AI usage, which is basically part of the function. Next is called as a ethics. See, in AI, the most important part is ethics. And it is a major concern when you have a AI adoption. Because AI ethics may be unfamiliar to security profession because it go beyond the technical control. I'll give an example. Okay, so I'm a security guy. I'm a CISO or I'm a security guy. For me, I want firewall monitor everything. So when he start monitoring everything, it's a breach of privacy. It's a breach of ethics. So sometimes it's not possible. I need to balance the security with ethics. Because if I focus on security, ethics will be compromised. If you focus on ethics, security will be compromised. Because someone can misuse this law and try to bypass the sensitive data. So we need to make sure when you adopt AI system in your organization, you need to balance how do you manage the ethics and all that. So ethical risks increase because AI can automate the decision. So for critical decision, human oversight is required. Any question in the exam talking about for critical decision, the most important last defense in depth, we required a human oversight. AI learn and adapt over the time, but sometimes it can be biasness, which can create an ethical risk. It operate with a reduced human involvement. What if AI can take some decision which can backfire? AI reject the loan. AI give preference to one set of people. So that is ethics. So key concern here is whether AI autonomy can create a harm or unfair the risk. AI autonomy means AI will control everything. So I need for a critical decisions, I want people to be involved, human to be involved. Because if you don't involve the people, if you don't involve the final decision authority as a human, it can directly impact the decision predictions and all that. Is it clear? So what is the strategy? So define the purpose of AI, which is very important. Consider the law regulation we have to comply. Use diverse and cross-functional teams so we get a viewpoint of everyone in the committee when you're building an AI. So AI should not be built from one dimension perspective. Include stakeholders, compare the AI policies, create a feedback, which is basically very important for the benchmark. So the requirement is ethical conditions should be discussed and documented. Risks need to be addressed. Organization should consider AI purpose, business context, which include the risk, region, industry, because AI will work differently in different countries. Then we need to see it should have a societal expectation and it should have a positive impact on stakeholder. So the common controls, what we need a human in the loop oversight. And think of a AI ethics control, as a guardrail. Guardrail mean control that makes sure the AI does not harm people and all that. So the first thing, they're talking about human in the loop oversight. This means human should review the important AI decision before any final action has been taken. So let's say example, if AI recommend rejecting a loan, Human should review the final decisions. That something is there. Okay, so AI can suggest, but human can supervise. Second is called as a AI Ethics and Compliance Committee. It means this group that review whether AI being used responsibly. It includes security, legal, and all that. So before launching any AI hiring tool, the committee should check the biasness, privacy, and all that. Third, AI code of conduct. So this defines what is allowed, what is not. So employer should not paste customer personal data into public AI tool. Next is a review of ethics control effectiveness. So control should not exist on a paper. They must test and review. So if company has a bias testing process, it should check regularly whether bias is actually working or not. Most important part, we document documentation of health, safety, compliance, and everything. So organization should document how the AI meet the legal safety environment. Okay, so let's say example, if I'm using an AI for a medical diagnostic tool, the document should show how safely testing, secure testing, privacy review, and all that. So no documentation, no evidence of responsible AI. The most important part in ethics is transparency and explainability. So user and stakeholder should understand when the AI is used, why it is made decision. So if AI reject any insurance claim, the company should be able to give a justification. What is the source you have used? That something is very important. Next is called as a fairness and bias testing. Fairness and bias testing mean AI should be tested to ensure it does not unfairly harm specific group. So we have to check whether AI treat group fairly. Let's say example, there is a loan approval. So AI should be tested to ensure it is not unfairly rejecting. So regular bias testing need to be done. Different diverse set of data should be there. The way we do the PIA in the privacy, similar we do the impact assessment. How this AI will impacting a people, society, and all that. Even for the ISO 42001, it's a requirement of audit. So these are the basic activities we need to have for the function. Next is basically called as a trust. So in this module, we discuss about privacy, ethical, and we should trust AI. Okay, but the biggest concern is the AI using deep learning, they have a black box behavior. So that's the biggest concern. So security team should understand how AI architecture may affect the network, permission, system, data flow, connected component. And for that, we need some documents. Document the data used by the AI. Document the data created by the AI, document all the AI process model design, document what is known and unknown about the model behavior, because this is basically build the trust. So when you launch tomorrow any kind of AI tool, and if you have a necessary documentation about this, it can build the confidence, it can build the assurance in the market. That's very important. The problem here is with the AI is the black box. Okay, so neurons are there. They're processing the data. They're doing end-to-end processing of data, but we don't know what is an outcome. So it creating an uncertainty for security, governance, audit, and all that. So we have to make sure to do the proper risk assessment to identify possible black box use case. And according to that, we can remediate. But if you really want to build a good trustworthiness among the AI tool, transparency and explainability is the most important part along with your documentation. The next thing is called as a safety. Safety is another important thing required because nowadays we have a Tesla cars, automations, and all that. So AI safety focus on preventing harm caused by AI decisions, automations, and autonomous actions. In 2022, there was an autonomous vehicle in US has basically crossed over the pedestrians. So we need some kind of a process in place if it's basically going to hurt any individual and all that. So we should take control over the things. Okay, so AI system with agency can act independently or semi-independently. So greater AI autonomy create a stronger need for AI governance. So when you're building an AI system, the safety question is who is accountable if AI cause harm? Can AI act safely, ethically without human control? What happens if AI decision conflict with human values? Which decision will be preferred first? Can AI explain decisions? All those factors we need to consider when you're talking about the safety. So what is the countermeasures? That's a good question. So AI can be misused for fraud. Non-sensitive data can be combined to create a false identity. We have seen in deep fakes. GAN are generally high realistic fake image and all that today in GPT and all that we use. So the required control is we need a human oversight, final decisions, strong governance for regular tests and everything, safety testing, output need to be monitored, and misuse detections need to be done. Deepfake fraud awareness need to be done. So for that, what we did, we introduced some supervision. So supervision is like, logging and monitoring, which is required. where we record all the AI input output, and on a regular basis we check all these logs, which give me the visibility how to improve my AI system. Second is AI observability, confirm in the exam, where we monitor the AI system performance, reliability, availability, trustworthiness. We introduce a matrix. In part E, we're going to discuss the matrix. Then next we have to check the source of data, the interface through which the model get trained, how the data was trained, what is the source, checking the data monitoring and all that. The AI tool running on infrastructure, we need to monitor the system health, compute usage and all that. We also need to understand how they interpret and how they're basically taking a decision. And the most important part is the human review is involved in taking a critical decision. So these are things we have to look for when we're talking about the AI supervision. Next thing is called as a part E, very, very important. In this section, we're going to discuss about first, the sequence of the entire program, okay, because it is very important for you to know, okay. When you start building an AI security program in the organization, it's not something you start from policy, no. First, we need an AI strategy, which cover the business objective, use case, value, stakeholder, which help you to set the risk appetite. Risk appetite is a driving factor for any organization. That's a very important part, okay. That helped me to build the policies, define the roles and responsibility, comply with legal, privacy, ethics, and accountability. Fine. It's not possible that I can able to build everything. So I need a risk management. So I will identify the risk, doing a risk assessment, impact assessment. If I'm using a third-party AI tool, vendor risk assessment has to be done. Now it's time to an operational. So here what happened is we selected a model type, data source, technical environment, storage, configuration, model selections, and everything. Fine. Based on that, I bring everything to build the AI system where I plan, collect, build, test, validate what we discuss. And then we introduce the further control, access control, zero trust, encryption, observability, privacy, agent technique, incident response, and all that. Is it working fine? We have a continuous monitoring process. And outcome is that secure AI, resilient AI, private, fair, transparent, and all that. So we start with the strategy, then we go for program, assessing a risk for the controls, then we introduce the controls in the architecture, we implement those controls, we monitor. So this is a very important part we need to understand. Now, when we're talking about AI security control, they are more complex than IT, because in IT, we know a particular output, but in AI, we don't know the output. Especially in the case of AI third-party tool, you don't have any internal visibility what controls they have. So control is depend on how the AI is used in the organization. Does it solving the internal business problem, improving a product development, using a third-party AI tool, building an AI model, developing AI models. So AI introduces a new risk from a data, model, prompt, output, automation, third-party, model training, and all that. What we need before implementing any kind of a control in the AI system is risk assessment, change management. Risk assessment identify the gap. And when you're introducing any change, it needs to go through change management process to track the accountability. Because these guardrails protect against both internal issues and external attacks. That's something we have to look for. So we need to see, is the existing security control maybe enough or we need to enhance? So we have to start with the gap assessment. Okay, so control should be selected based on the AI type. That's the primary thing. What kind of a AI you have? What kind of a use case we have? So let's example, I'm using a chatbot for a basic user. We need less controls. We are using chatbot for a patient analysis report. We need more controls. We also need to check the business impact. How it basically impacting the data sensitivity, threat exposures. All those things has to be done. So that is why in AI security, we talk about 4 types of controls. Technical controls, operation management controls, SDLC controls, and ethical and human value controls. That's something we need to understand. Okay, so first we're going to discuss about the technical security privacy control. In that, the most important part is you need to ensure the good quality data. Now, when you're talking about data quality play a very important role, because if you have a right data, it can produce a right output. A good data lead to good AI, bad data lead to the bad AI. And we're discussing since from last 2 domains. So we have to make sure the data should be accurate, complete, relevant, usable. And we need to monitor the data quality continuously, because today the data which is relevant might be not tomorrow relevant. So we need to resolve the data quality issue before using data in the AI model. There's no point of adding error data. Second thing is that when it comes to model systems and all that, we need to have a least privilege and role-based access. Easy to manage role base. On a granular level, we can have a least privilege access. Let's say example, we have a subject 1. We have a subject 2. We will give the necessary right to perform the duty. And if it's a AI tool and they need to log into AI tool to manage the things, if it's a critical account, make sure it should be protected with MFA. Any question in the exam talking about the most effective control to protecting the AI system and data sets, you need to enable the MFA. Monitor the access regularly, perform the periodic access certification, recertification, which is part of a requirement. Now, if you're running a multiple models, let's take example, you need to maintain the uniformity, and that is start with the configuration management process. Now, what if the model is not running with the same configuration? We are running the same parameter, same business, and we are running a different model. For that doesn't make sense. If you're looking for the uniformity of the AI systems and you want a uniformity across the organization, start with configuration management, because that gives the visibility about you have approved AI systems. You can configure system based on risk and security requirement. Any kind of a changes in the configuration, it need to go through a change management process. If you have a proper configuration management, you can able to detect the vulnerability as early as possible. Along with that, we need to perform end-to-end testing. The most effective testing is adversarial testing, because that's how you can able to test the robustness of the AI system. Make sure you should also test for bias, fairness, and unexpected behavior. Along with that, we also look for privacy control. We already discussed about different type of privacy functions. We need to protect data, use encryption, anonymization, de-identification. Anonymization and de-identification we have to use in that case when we feed the PI data into the AI model, and we want to make sure identity should be maintained secrecy. Privacy impact assessment has to be performed, because make sure it should not impact the privacy negative manner. Protect data using access controls, maintain the data architecture, and if possible, perform the data minimization, because more data you collect, more accountability comes to you. Along with that, what if tomorrow any incident happens? So we need to have a proper incident management process to reduce the impact. So example, incident of model inversion, model poisoning, AI misuse, data breach as per GDPR 72 hour, as per India 6 hour, or as per the regulatory requirement, we have to report the breach as early as possible. We also need to make sure we should have a proper response plan which define how to identify the incident, how to contain, mitigate, and restore the AI process. And one more important thing, you don't need to create a separate incident management process. You can use the existing incident management process and update the AI system in that. That basically gives the clarity and everything. Now, the next important thing, we talk about the operation lifecycle management. What if AI system is running in the organization? So we need to maintain day-to-day activity. So we have to make sure we should have a proper data flow control diagram for logical physical context, show how data is collected, processed, enriched, and it helps the stakeholder to understand data handling. And according to that, we can able to implement the control. Make sure you should have a proper documentation for model architecture, algorithm, training data, performance, expectation, and maintain the traceability. It's very important for the regulatory requirement, because if you don't have a data traceability and all that, you cannot able to validate the data. And make sure you should ensure the AI lifecycle activity follow the approved governance requirement that reflect a good parameter. Now, what if you change the model? What if you change the data? Make sure you should have a proper version tracking of that. It's very important, because you need to have a version tracking for the integrity purpose. So let's take example. We have a model version 1.1. You update to version 1.2, but 1.2 failed miserably. Thanks to the version history, we can able to roll back to version 1.1. It works in a similar fashion, the way the document works, right? If document is basically crashed and closed, so you try to restore the previous version of the document. That is why version is very important, because it ensures the reproducibility and rollback. Along with that, any kind of changes in the systems on a regular basis, make sure you should follow the change management process. Make sure you should have an emergency process, and that's very important. One more important thing you need to understand here is that, let's say example, the model was trained on 2026 data, January. Now is basically July. So there will be some new data need to be trained, new parameter need to be done. That's why the continuous monitoring and logging is very important, because we need to monitor especially critical AI systems. And why? Because once you deploy the model, what is model drift at the later stage? Understood? But it means that, okay, model initially which used to give accurate information, now it's not giving accurate information because of lack of drift, monitoring and all that, and that lead to the model drift. So that can be the model drift can be only addressed by the continuous monitoring. We need to regularly monitor the model, look for the deviations, and according to that, we need to update the process. That's a very important part we need to understand. Now, when it comes to AI systems, they also play important role in SDLC because some AI system you build from scratch. So let's say example, you got a requirement, you want to build a AI project. So it start with the project management activity. Project has a start and end time. So AI SDLC control depend upon the development approach used. So in the case of DevOps and DevSecOps, the control will be different. And in the case of waterfall, it will be different because in waterfall, you move from phase 1 to phase 2. You cannot come back. But in DevOps, on a regular basis, with the help of iteration process, we can able to validate. But there are some reasons why the AI project get failed. When we have an unclear requirement, let's say example, we understood something else, we built something else, or sometime incomplete requirement, lack of support, poor collaboration. So if you're looking for a most effective way to a successful AI project is collaboration, because collaboration quality can strongly affect the project success. That's a very important part we need to understand. Along with that, we have an ideation phase where we document the problem AI system is meant to solve, align the AI goals with business objective. That is the only way we can able to have a success. Identify all the possible adverse outcome or harm before we design things. That's also very important. Do the technical design of the document. When you design, you check the data source, quality, optimization, and confirm whether data is purchased, acquired. That's a very important part. Then deploy in the production. Make sure your test environment should be isolated from development environment. And a good SDLC is the one where you define the problem, align with business, design with data controls, and manage the deployment. That something is very important for us to understand. Now, next is called as ethical and human values. It's a very important part. When it comes to the ethical value, because you are introducing AI, okay. Now, when you're introducing AI, it should not create any kind of discriminations. Okay. And if you're introducing AI, especially in Europe, and that going to impact mass or multiple people, make sure you should do the ethical impact assessment to understand how it creating a negative impact for the people. If you're collecting a PI data for your AI model is going to use data for the learning and all that. Make sure you should have a consent management. Consent management basically mean we provide a user with the option to opt out. We have seen recently in Instagram also. And make sure you should document track the consent for AI model training. If someone has requested to delete the data as per right to forgotten practice, we have to delete the data. The biggest concern in the AI system is biasness and fairness, and that is only happen because of the data imbalance or lack of complete data. So we have trained the model on a one particular portion of data, and based on that, it taking a decision. So the biggest concern in biasness is basically a lack of population data. And we can reduce the biasness with a secure ethical development practice, review the training data, validate whether model result fairly, and monitor the model drift and unfair outcome. That's the biggest thing we need to check. Everything, it starts with the transparency. If your model is not transparent, especially in the deep learning and all that, it will not build the trust. So we need to disclose when AI use decision making, document the capability, share the relevant information. So in AI model, what happen is we use a explanatory tool such as LIME and SHAP. Okay, what is that? Let me explain you. So before I jump into the detail, let's understand what is LIME. LIME actually stand for local interpretable model agnostic explanation. Okay, local interpretable model agnostic explanation. Okay, so it explain one prediction. So they look around only one specific prediction and find which feature influence it. Let's example explain, explain why one customer was denied a loan, or why one image was classified as a CLAT. So that is basically called as a local explanation. Second is called as a SHAP. SHAP, it means Shapley adaptive explanation. It explains both individual prediction and overall model. So it calculates the contribution of every feature, and based on that, it provides the information. So it basically talk about the model transparency, biasness, analysis, regulatory approval. Okay, so it's fair contribution for every feature. Third is called as a rule base, where we explain the decision using a predefined rule. We using like business rules, compliance systems, and all that. So let's say example, there's a customer A. Okay, so customer A, let's say example, give me a second. So we have a customer A. The loan was rejected. So Lime basically explain only the decision like income, credit score, existing loan. So it does not explain the entire model. It just gives the high level information. But on the other side, Shape or SHAP, which is will basically take the information about income contribution, credit score, existing loan. It also tell you, across all the customers, the features and why they got rejected. Rule based is basically have a condition. So the question talking about one prediction, Lime, one prediction, an entire model, SHAP, human return, if and true, answer is basically rule based. That's how we basically take the example. Okay. Human oversight is important, definitely, because and that is only possible when you have a committee, because we need a viewpoint of everyone. We need to ensure the human review for AI decisions and output, create an appeal for AI-driven decisions and independent AI review. That something is part of the metrics. That something should be there. Now, the next thing is called as access control. As I said, access control is very important. If you're looking for the governance perspective, make sure we should have a centralized access control policy by which we can able to enforce everything. If you have a department-based model, you can have a role-based access control. Make sure you should validate only the authorized user can access and all the data. Remove the access when not in use, monitor the access model, and make sure everything should be governed properly. That something is very important part we have. Next is called as zero trust. So you will get 1 or 2 questions on the zero trust also, which is very, very important. When you're talking about zero trust, is it clear? Okay. It's very important to know the zero trust from the AI context and everything, because if you take an example of zero trust function, okay, it is introduced because identity is a new parameter and the people are joining from multiple locations. So let's say example, before 2020, what used to be happen is, this is my organization. This is my DMZ. This is my internal network. So we have a public facing systems in the DMZ. So user normally do the identification, do the authentication, and based on that it give access. That's what we did. Now what happened, based on that he got access to the resource. Okay. What happened? Hacker misused this credential. Based on this authentication, he can access this, and there is a possibility he can access to L. Because traditionally what happened, we use the concept of economy of mechanism, which is also called keep it simple. It means log in once, access everything. But problem here is that if hacker hack the credential, he can disrupt the things. That is why today we introduce zero trust architecture. In zero trust architecture, whenever user authenticate with this resource, he can access only this resource. If you want to access other resource, again he need to go through IEEE access this resource only. So we have a micro segmentation for every access we have. So zero trust mean do not automatically trust everything. Okay. So in normal IT security, we verify the user, device, network, application. But in AI, we must verify even more things. User access, data access by the AI model behavior, internet access, system behavior, system action. So zero trust in AI, never blindly trust the user, data, model, output. We need to validate that. Because what happens is AI should not be trusted just because it looks smart. AI system can be still use wrong data, produce a wrong output, hallucination, expose sensitive informations and all that. So zero trust able to, you should have a visibility to assess the things. Okay. Can AI perform the task safely, reliably, accurately? We need to ask yourself. Example, like if AI used for a fraud detection, is it accurate? Is it reliable? Is it tested? So ability, can I do this job? Second is integrity. Is this AI using a clean and trusted data? Okay, can we trust the data and model? Third is benevolences. It means, will the AI avoid harm? If AI hiring system reject the candidate unfairly, it may be technically work, it still cause the harm. So that's something we have to look for. So if you're deploying the AI tool for the internet access, this is a very important part of Gen AI and LLM system. If AI can access the internet, it may read the malicious content. It can follow the hidden instructions. It can access the untrusted website. It can leak the sensitive data. So internet access should be tightly controlled. So key controls what we need here is deny internet access where possible. It means do not allow AI to browse the internet unless there is a real business need. Second is apply access control if internet is required. It means if internet access is required, define who can access, what can access, where the AI can access. Third, block the restricted unsafe website, which can do the unparameters functions like use URL filtering, spam filterings, and all that. More important is basically limit the AI access only to approved data source, or do not allow LM to use externally data blindly. So this happened with one of my company. So company, what they're using is they're using an internal AI assistant. Okay. So without zero trust, employees simply ask AI to prepare the report, search for the internet, unverified data, include wrong risky information. With zero trust, AI can only access approved internal document. Sensitive data is restricted. External websites are blocked. AI output are validated. So that's how we basically use this particular matrix. So hope this is clear to everyone. It's very important for us to understand this matrix so that you can have a complete visibility in everything. So zero trust is not limited to only infrastructure for your information. It is used for the multiple reasons. That's something we are using. So do you know what are the practices we're doing in traditional zero trust? Like we having IAM and MFA, the same we can have for AI model, dataset, API, and outputs. We can have a network segmentation where we limit the communication between the AI system, data source. We can decide which data will be public and all that. Third, protect AI data across the lifecycle. We can encrypt the data when data is not in use. Use DLP to prevent data to go out. Detect the unusual system model interaction with the help of user entity behavior analytics tools. Doing a continuous monitoring. The best way you can monitor is enable the anomalies, so we can look for the suspicious activities and everything. If any incident happen, we should have an incident response process. Use threat intel to update the things. So that's something we can have. But in a form of administrative control, we can have a AI acceptable usage policy. It's high time that in the organization we need to define how to use AI, when to use AI, and what kind of a data to be used in AI, because it can basically guide the staff how the AI tool may be used safely. What is a good policy? That's a good question and can be asked in the exam. The good policy is the one which aligns with the business goal, ethics, and organization culture. End goal is that only. And we need to balance the AI benefit against the risk, because the AI we are using for speed, scalability, and all that, but sometimes it can backfire also. So we need to include the expectation of allowed AI tool, restricted data, prohibit access, and that is the most effective way you can able to improve the behavior of the person. That's something we can plan it. So according to that, we can able to validate and everything, which is very important for us to understand. Now, one more important thing, that it's not necessary the AI tool is always working like that. We need to do the regular audit, because we need to ensure the AI should work as per the business requirement. So we need to track how the AI decisions are made from input to output on regular basis. We have to validate. We need to have a proper traceability, how the data was used throughout the system. Metadata is very important because it captures your inputs, output, model details, and everything. And audit basically also help to reduce the black box concern and support the accountability. If you get a question in the exam, you're dealing with the AI model using a deep learning, what is the best way you can able to track the visibility? The only is audit, because audit drive the traceability, and traceability prove where the data came from, how it changed, and more important, how the AI made decision. One more important thing we need to understand is when you're using a third-party AI, you need to do the assessment of the vendors. So we need to see how the technology was integrated, the data what they have used, do they have a proper consent for that, how long they have retaining a data, what is the type of testing they're doing for model validation, API security. And we have to make sure you should add the AI supplier chain management in your audit program, because if you don't assess the vendors, if you don't assess the model, API, data handling, business practice, it will be a problem. So you have to look for this particular thing. Now the next thing is called shadow AI. Now what is shadow AI? As per your company, there is no AI tool. Employees are not using any AI, but internally they're using AI and you don't have any visibility. That is called as shadow AI. Unapproved AI tool or application used by employee. And it can cause data leakage, compliance violation, reputation damage, loss of proprietary information. So what is a countermeasure? First, if the question say, what is a primary thing you can address shadow AI? Create shadow AI policy. And most effective control is user education, because no matter you have what controls and all that, people will not going to listen. Make sure you should have a CASB, cloud access security broker, to monitor the data visibility and all that. DLP is there. data loss prevention, UBA, network monitoring, data flow monitoring, procurement budget control. These are some of the controls we need to have for the shadow AI. So unapproved AI that create a hidden data compliance security risk is called as shadow AI. Now, if tomorrow AI generating a hallucination, leaking sensitive data, it is an incident. And we don't need to create a separate incident management process for that. We can use an existing incident management process and we can integrate the AI into that. So organization must define what if qualify as a AI incident. Example, data breach, model misuse, algorithm biasness, unsafe AI decisions, ethical violation, third-party violations. So incident response help to reduce a business, legal, security, reputation impact. An AI incident may require a different response step than a traditional cyber incident. So we need to have a contingency plan also. What if AI system fail? What if third-party data fail? What is a model unavailability or inaccurate harmful AI output? So AI incident management extend the normal incident response to cover the AI fairness, biasness, safety, and all that. That's something we have to look for, which is very important for us to understand. Now it's a high time. We also need to provide the awareness session. The similar way we're providing a security awareness session, same way we need to provide the AI awareness session, because knowingly and unknowingly people using AI, which can create a big concern. So that's something we have to look for. So one thing is that shadow AI, information leakage, everything can be addressed with the help of awareness sessions. Ultimate goal of awareness to make the employee aware about his responsibility, and it is only possible if leadership support is there, because they should clearly communicate what is the approved AI use, prohibit AI use, current and new policies, and security expectation. That's very important here. And when you're creating a awareness session, make sure your session should include the security, privacy, ethics content, benefit of AI, how to understand the AI output, interpret the AI results, bias detections, explainability of black box risk, model drift, and adversarial AI. That's something we have to look for. And it's very important for us to understand also. Now, it's very important once you deploy the model, it's not necessary it will maintain the same state of data. So we have to do the continuous monitoring. Why are we doing that? Because ultimate goal of continuous monitoring is to make the AI secure, reliable, accurate, and aligned with the business need. If you get a question in the exam, what is the primary benefit of continuous monitoring? We have to make sure AI continuously align with the business need. So question is what we need to monitor. We need to monitor the AI output for inaccurate result, hallucination, biasness, abnormal behavior, and all that. And we need to track the integrity of AI model through the model drift monitoring, model behavior monitoring, threat intel, and third party integrity check. So that's something we have to look for. And for that reason, we are using one also monitoring called drift monitoring, because continuous monitoring addresses the drift. Now the question is, what is model drift? Drift basically happen when model performance degrade due to the change in the data, context, and output. Let me explain you. We have built the AI model in 2025. And according to that, it working fine. But in 2026, the context got changed, data got changed, but still it providing an old pattern. Understood? So model drift happen when AI model performance become weak over the time and because of the real world data change. So fraud detection model was trained on fraud pattern on 2023, but in 2026, the attacker used a new fraud technique. So the model misses the new fraud case because still understand the old pattern. This is called model drift. Now the question is why the model drift happen? The customer behavior change, attack pattern change, language or prompt change. That's something there. If the question say performance degraded over the time, model drift. Model was accurate before but now wrong, model drift. Real world data change after deployment, model drift. So that's something we have to look for. So one thing we need to understand is we have to look for drift can cause for multiple reasons. It can cause a wrong decision, poor predictions, and outdated output and all that. One more important thing we need to understand the point. So when issue appear, so we have a model drift. Model drift after deployment over time. Okay, so when the issue appear, model drift happen after deployment. Okay, now what is overfitting in this? Overfitting mean during a testing or new data evaluation. Okay, why this is happening? Because of real world data change. And overfitting is model memorizer training data. So here what happened, model drift is very much correlated with the overfitting and all that. So the important question here is that what we have to address here. So we have to look, is the important prediction still valid? Has a relationship between the input output change? Is the model learning is unexpected behavior? Is the model too specialized or still generalized? Or it performance cross the defined threshold? So model performance change over the time and continuous monitoring answer that particular issue. Next is called control for AI enabled threats. So train, employ and defake, that's very important. Use AI powered detection for suspicious email content. Run phishing campaign. Use adversarial testings, okay, to validate the models. Verify the precision recall F1 score. If you're looking for the most effective testing for precision recall and F1 score, answer is adversarial model. Info strong password MFA, which is very important as for understand. When you're presenting any kind of a matrix to the management on the security matrix, so we have to present this matrix. Preparedness, patch status, software updates. It show whether AI system supporting infrastructure. Shadow IT, shadow AI, how many device count, so it can detect the unauthorized tool system and all that. Intrusion attempt, breach count, measure attempt attacks. DLP effectiveness, show whether sensitive data leakage has been prevented. Awareness training, percentage of people have completed the sessions and percent of people have reported the incident. Ultimate way to measure the awareness training is percentage of people report the incident and number of incident violation has been reduced. And AI solution performance, we can able to track by reducing false rate, model drift frequency. This is very, very important for the exam. So by this, you can able to track whether AI system remain accurate, reliable and usable. As this is the last domain, I want to share some snacks. Okay, so this is basically last minute AI risk you should know. If the question or select the answer when we say representative population. Choose when question say training sample data does not reflect real user, target population, demographic deployment. But do not choose when issue is only about one class being rare. Okay, wrong sample equal to population issue. Select the answer data imbalance. If the question say minority rare class is missed, data sets has too many example of one class, too few of other. Do not choose when model perform poorly on the on classes. Rare class equal to imbalance. Overfitting, select the answer if the question say model perform very well perfectly on training data but poorly on new data sets. Okay. Underfitting, we have to select in that case if the question say model perform poorly on both training and test data, model is too simple. If the question say model performance degrade over the time after deployment due to the change, data behavior and all that, it's a model drift. Training data set is manipulated, corrupted, injected, malicious during a training phase. The answer is basically data poisoning. Don't select when the question say model weight. Model weight, parameter, architecture, pre-trained model are tempered. That is a model poisoning. Okay, decision cannot be explained, justified. The answer is basically black box explainability issues. That's something we have to look for. If the question is talking about attacker change the input slightly to avoid detection, the answer is model evasion. Attacker inferred the sensitive attribute or reconstructed training data from model output. The answer is model inversion. Attacker determined whether specific record was part of training data. Answer is membership inference. Actually, by inversion, we can get a membership inference also. Attacker steal model, weight IP, recreate model through repeated queries. Then answer is basically model theft and extraction. Training data sets, notebook, repository, storage location, export data. Then answer is training data leakage. Output unfairly impact a group or protected characteristics. Then answer is bias and fairness issue. So these are the top risks that you should know. So now next thing is called important think like a manager. See, for AISM, do not think only like a technical engineer. Think like a professional responsible for AI governance, risk management, business impact, privacy ethics, security architecture, stakeholder trust, and legal regulatory requirement. For question in any scenario where they're talking about organization using AI, what risk does this create? The best answer is identify the AI use case, identify the roles, assess the risk before action, protect data, model a business, use governance, documentation, testing, and human oversight, not implementation. Next thing is that AI governance ensure AI used in control, ethical, secure, legal, and business aligned way. So key governance focus is strategy. Then we create a policy, then external use policy. We need to give a clarity, roles and responsibilities, steering committee, legal privacy review, vendor or third party oversight, and more important, monitoring and reporting. We have some roles in AI like board is accountable for direction, senior management approve the priorities, AI steering committee review the AI use cases, risk control, CISO will manage the AI security risk, Privacy, legal team review the consent, lawful basis, data rights and contract. Risk management is all about integrating AI risk into the enterprise risk management. Internal audit, validate the governance, and AI user follow the approved usage rule. So we start with the AI strategy, because AI strategy explains why an organization using AI. It should be aligned with the business objective, customer value, operation and improvement, innovative goals, risk appetite, legal, ethical. Then based on that, we create a program. Program include the governance structure, policy, roles, inventory, risk management, vendor management, monitoring, and everything. If you want to convey the management on the AI, start with the business case. You should address what problem is going to solve, why AI is needed, what are the cost, risk. And whenever we go for AI, look for the cost versus value thinking. Cheaper AI solutions not automatically better. The right consider will be business benefit, control cost, compliance exposure, reputational damage, operation risk, and human impact. That's something we have to look for. So this is all from my side. Do let me know in the comment box how do you find my AISM series, and if this was useful for you, do share in network, because it really required a lot of efforts to create this free content in the time which I spent on the content creations, and it is just based on a feedback. I just wrote this entire series of AISM Domain 1, Domain 2, Domain 3, and let me know how does it create an impact on your certification preparation. And if you pass the exam based on my content, do give credits. That is the only thing I expect from you in returns, because I always want the training to be free, and education should be available to all. So this is all from my side. If you're new to the channel, do subscribe to channel and click on the bell icon to make sure you should not miss the future videos on a similar topic. Thank you so much.